Hello, hello, hello. Oh, let's move this a little bit. Where are we? That's me. And that one. Oh, no. Yeah, totally professional here. Hello, hello. Hello, Ian. How are you? Welcome along. And welcome along, everyone else. I don't know if anyone else is... Oh, a friend of mine. He's slightly suspicious now. Hey, Zuperdan, how are you? Yeah, I'm all good, all good. It's a Tuesday, had a Tuesday off. Hey, Graham, Amiga is now following. Thank you for the follow. I thought you were already a follow. Oh, Luke. Jeez, I haven't spoken to him in a little while now since the podcast got suspended. Arabundi, welcome along. Hello, hello. Ah, very good. Very good. Was he sorting out something on the Electron? I remember I did a recap on Electron a while ago. It was the first time I'd ever touched one. Oh, thank you very much for the subscription. Oh, look at this. Oh, yeah, thank you very much for that. Yeah, the Electron seems to be a nice little machine. It's oh, of course, yeah. Oh, very good. Hey, I'm Immortal. Welcome along. Welcome along. Yeah. So I'm going to get started now in a second. But yeah, that's cool. Those covers are really nice. If anyone's familiar with, or if anyone isn't familiar with them, you know, RetroReady.1. A friend of mine, Lucas, and his wife does embroidery things, you know, and sewing stuff, and she has a line of, you know, fabric covers for retro machines, and it's you know, so they're really nice, you know, with the like nice embroidered logo in the corner and stuff. And she does custom jobs as well, but I think I can't remember what oh, it's So Ready, SEW Ready is her thing, but I think Luke has them on his shop as well. But yeah, they're really nice looking covers. Actually, that reminds me, he's promised me one of them for the next in-person Scottish Amiga group meetup as a prize. So I'll have to sort that out whenever we do that again. But yeah, no, it's the Electron's an awesome little machine. You know, for what it is, it's cool, very impressive. Well, welcome along, guys. There's been quite a bit of chat in the Discord there in the last day or two. But one thing that has come up was basically to do with pointers, and not not pointers. Actually, like using registers and using assembly language in Blitz, and so. Oh, nice. Yeah, so I had, just before the stream started, I have done this very, very simple setup, and it's not extremely complicated, but it just demonstrates how the put reg and get reg commands work, and they are well, basically they are sort of a bridge between like Blitz land and assembly land, if you like. You know, so what they do, so the getReg command pretty simply fetches a value from a Blitz variable and puts it directly into one of the CPU registers. Okay, so getReg D2 comma B here, you can see. What that does is that will take the value of the variable B and put it directly into register D2. So what I'm doing here is I'm taking a little bit of a shortcut doing it. Is you got the mul-u operand. Now this is actually assembler, and that's an unsigned multiply. Okay, and it takes two word-sized variables and multiplies them and gives you a long in return. But what it does is it takes two registers and it stores the result in the second register. So one of your numbers gets overwritten by the result. Now, this is taking a bit of a shortcut, and it's just sort of to demonstrate how this works as well. That when you create a function like this, like the multiply function, just called mult, I've given two parameters, two word parameters, but these are automatically loaded into the data registers. So D0 and D1. So A and B go into D0 and D1 automatically. So I'm just, you know, so you could do this with D1, D0, and that would be fine. It would just work. But just to show that getReg is actually doing something, I'm loading the value of D1 into, like, the value of the variable B into D2 instead. Hey, what's the story? A group of Italians here again for all the stuff he doesn't understand and has no interest in, but I appreciate you being here. How are things? Yeah, so this multiply is taking the D2, which I've just loaded from B here, and multiplying it by whatever's in D0 and putting it back in D0. Okay. Now, normally, you have to do a function return on a normal Blitz function to return a value, but because this is an assembler function, what we've done is it returns the value in D0 directly. So you don't actually need to do a function return. You just do assembly exit, and that takes the value that just exits your it just exits the assembly part of the program and doesn't try to return a value from Blitz. It just takes whatever's in D0 and that's it. Like so D0 will be your result. So when we go further down here, we can end print the result of multiplying 5 by 10. We should get 50. But also up here we're putting hey, welcome along, Terrible Fire. Yeah, but that's the standard way of doing it. What the thing is that when you use Blitz in a function, it kind of stops that working. No, there isn't a start ASM. It's not. Basically the entire function has to be pretty much like ASM functions, or else it kind of messes up, because the Blitz functions will use those, because Blitz commands will use those registers themselves and mess it up for you. So you can't really mix them unless you're, well, in a function like that, you just don't mix them. You have your function written in assembly, and that's what you do. You know that, you know, if you put like an end print in there, for example, that will just, like, you know, mess up all your registers. So there's no real point in doing it. I wouldn't bother even trying that kind of stuff. Some do, some don't. It just depends on what the Blitz commands do internally, and it's hard to tell without like disassembling them. But basically, yes, that's it. So your function is a clean start to code. So once you start in there in assembly, that is all going to be assembly. That's where it starts effectively. You can do inline stuff in the main body of code as well, but again, you have to be careful what's happening with your registers. But yeah, so just to prove that putreg works, putreg is the opposite of getReg. Yeah, that's it. Because especially if you're using all sorts of external functions that were, you know, that were never intended for that kind of use, they can be doing all sorts of things. But yeah, so putreg does the opposite of getReg. That takes what's in a register and puts it back into a Blitz variable. So we're taking the result, which is in D0, and putting it in variable C, which is a global, and it's a long. So we've done that up here. And so at the bottom here, we print the result of this, which is returned in register D0, and we're printing variable C, which has manually been given the value of D0 as well here. So like basically when we run that, we should get 50 and 50, which is exactly what we expect. So that's the two different ways of transferring values in and out of assembly code. Well, I'm great. What's the story? And how are you? But yeah, so basically, I don't know if either of the guys who were asking about that are here. Possibly not at this point. But anyways, I said I'd get that out of the way first, and it's at the start of the video, so anyone can go back and watch it quite easily. It's excellent. Good to know. Good to know. So yeah, that's there anyway. Like now in Ami Blitz, in Ami Blitz 3, you've also got a get D0 and put D0, which are, for whatever reason, a little bit faster than put reg. I suppose it doesn't try to interpret what register it is. It's literally just the one register, get D0, put D0, and that's handy for, you know, just setting your return values and stuff like that. But it's basically the same thing. It just I think it just saves a couple of cycles. But yeah, so that's, yeah, there's the there's the explanation for that stuff. Anyone got any questions on that? You can come back to me with questions as well later on. I can always have a look at it again. But I think that's basically the simple bit. Once you start getting more into assembly, I'm out of my depth, because I can kind of fumble my way through it. But I'm definitely not going to say I'm definitely not going to attempt much here, because I'll just embarrass myself. But you know, this yeah, basically that's just showing there. It's pretty clear. Registers coming in and out. You cannot yeah, so you can have up to 6 parameters, and they go into D0 to D5. Okay, I think D6 is the stack, so you can't touch that. But there is a bug, and I'm trying to remember exactly what it is, with some of the parameters. I think D5 maybe gets corrupted in certain circumstances, or there's something funny with the older versions of Blitz, and it's fixed in Ami Blitz 3. And you can also, in Ami Blitz 3, add more parameters, but they get put on the stack instead of directly into registers, so you have to just remember to pull them off the stack. Yeah, I think that kind of covers it. If you use Blitz in there, you're going to mess up your registers, because it'll expect to return a value, and it will copy that value into D0, and you'll lose whatever you put there. So just bear that in mind. That's what a function return does. So yeah, just bear that in mind. So you use assembly exit instead, ASM exit. Okay. Dun dun dun. Now, what were we going to do? I'm just trying to remember where we were. So I'm going to load up. I'm just going to keep that open there just in case. Where were we? We were going to look at yes, we just looked at double buffering the last day in Blitz mode. So and sort of moving an object with nice smooth, no corruption or anything like that. Oh no, that's tutorial 7, wasn't it? Example 2. Okay, so that's it. That's the double buffered one, and that's the double buffering one. So let's just compile and run this and see. Hey, excellent. Oh, look at that. Now, the last stream went through hours of things with nothing. Now we've got all the fun of the fair. I think that's possibly just because I had the wrong directory set. That's what happens if you don't have the right directory set and tries to load a file. So let that be a lesson to you. Where it goes, what was that, 7 and example 3. Now, what we're going to do now is turn on the debugger and compile. Yeah, it just didn't find the file. So yes, that's what it was. We'll just get rid of the drive and that shouldn't happen. Out of memory, eh? This is not gonna go well. When when you get an out of memory error, it's never good, because whether it's out of memory or not, something bad has happened there, and it's got stuck allocating all the chip RAM or something. Okay, one more go quickly before I switch back to Ami Blitz or Blitz Basic. Yeah, this is actually under emulation, so it is not your fault. But you'll be glad to know. But yes, otherwise I would be blaming this dodgy hardware from up the road. Yeah, let's see. Now we will try it with the debugger on. Hey, it's working. Way. Now, there we go. Our favorite smiley face is back and moving smoothly. No, I did it under emulation just because rebooting is so much quicker. Although I did want to do it with a bit of, like, you know, a higher resolution, but then it didn't. You know, it's probably, the text was probably a bit too small to read and stuff like that. So that's all right. Okay, the directory book. Yeah, I found that you always need to set the directory because it saves. If you don't, it basically saves it as the executable. The executable directory is kind of the Blitz directory. You see, and so if you've got files, because that's where the Blitz, the Blitz process is. So by default, it runs with whatever the current path of the Blitz environment is. And you only change that by creating an executable. But once you've created the executable, you have to resave your source to save that in the source properties. Because if you open an AmiBlitz3 file in a normal text editor, you'll notice that there's a big comment at the top of the file that contains all the AmiBlitz3's parameters, including the current directory. And so you actually have to save the source to preserve that property, the current directory property. And just show you for example. Let me see. I'm never going to be able to find this, am I? Because this font is horrible when you don't have the true color. Let's just look at any file. Let's see. Oh, bitmap test. Oh, that's an executable, isn't it? Oh, give me some source. Give me some source. Projects. There has to be something in here. Okay. I'm getting this funny corruption on my icons as well. So it's a feature, yes. But yeah, okay. So there's the exe path, and that is set in the top of this. That's your source code. And basically, AmiBlitz3 doesn't show you this section, and there's where the actual code starts. Is here. So all that other stuff is basically config data, and that in Blitz2 is saved in the .extra file as a binary, I think. Whereas they moved it to the source so you can edit it more easily, and it's not, you don't have to remember to move two files whenever you move source around, and you lose all that property. So that's yeah, that's the thing there. But if you see, the thing is as well, if you haven't changed your source, I don't think clicking save does anything. Do you know what I mean? If you haven't changed the actual code, so just going into the main code and pressing space and delete is enough to trigger it to think it to be modified. And yeah, look at that. I don't know what's going on here. I occasionally, yeah, I don't know. Anyways, let's run it for a while until it falls over. And but yeah, so normally if you just press space and then delete, I don't know why it's highlighted a square there. It's enough to show that it's been modified with your little star down here, and then once you save it again, it updates the directory. Okay, so we're happy with our, that's what we did the last time, the double buffering. The next, what were we going to do? Tutorial 8. Let's move on to the next tutorial. These sound interesting. Is it demonstrated display in Blitz mode and showing a bitmap. the love of God. Yeah, I don't know what's going on there. And I presume it's related to this corruption. Something's allocated an infinite amount of chip RAM or something like that. Jesus, it ran perfectly the last time. Okay. Now, what was this even doing? So this seems like a step backwards anyway. So yeah, we don't need to look at that tutorial, but we're going to reboot again. Talk amongst yourselves. This was so well behaved the other day. So that's tutorial 7. Okay. Okay, let's go. Tutorial 8. So I can't remember why this was even a thing, because that's just displaying a bitmap. That we've created, and it just draws a few lines on the bitmap, random lines, and then displays it. Switch on the debugger, and that's it. Okay, that is not a big deal. We've already done that kind of thing, so but it just picks random colors, and that's fine. So let's load a new one. Example 2. Okay. Scrolling around a large bitmap. Hey, there we go. Now we're getting somewhere. And what are we doing? And this is basically scrolling based on the joystick position. So let's run it and see if it crashes for us. Oh my god. I genuinely don't understand what's happening here. There's plenty of chip RAM there. Well, what I'm going to do is I'm going to just get rid of that background pattern just to see, just in case. Okay. Now we'll reboot and we'll try that. Jesus. Yeah, I probably could. That's probably a way to go, actually. But then I don't know how it will handle switching screen modes. But yeah, that might be an idea. That's a good idea, actually. So let's well, we'll try it without the background picture there, just for now anyway. But it is ran, you know, anyone who's here there on Friday or Saturday when the last stream was, will know this just, all of this just worked. The joy of it all. But it shouldn't need much chip RAM. Like, that's a small, these are small bitmaps. Yeah, exactly. Okay, now at least we have our screen working. So this basically, you just scroll around this with the joystick, and you know, that's it. Simple as that. But what that looks like is now, what was the quit button? Oh, it was fire, wasn't it? Yeah. Great. Yep, that was it. So that basically all that's doing is scrolling around. Oh, I think we did touch on this in the last stream as well, actually. But basically, this is yeah, it's just creating a bitmap. So it's the simplest way of scrolling. So there's no actual like redrawing of anything going on. What we have is the we're just creating a bitmap that's bigger than the screen. Filling it full of random rubbish, and we're using display bitmap. So instead of just doing display bitmap 0, 0, we have X pause and Y pause, and they are whoa, just torrential rains just after kicking off here. Don't know if you can hear it, but it's quite loud out there. Yeah, so we've got two variables, X pause and Y pause, and they start off at 0, 0. So we start at the top left of the bitmap, and then as we just go through this loop until joy B1, until one of the fire buttons is pressed, and basically we just take X position, and add on the joy X and times speed. So speed we're saying is 5. Okay. And what this will do is it will add on Now, this is kind of shorthand. It's like plus equals in C, but that's or increment in C. But this is x position plus x position equals x position plus joy x1 times speed. So basically, the joy x function returns -1 for left and +1 for right. So if you multiply it by 5, you get 5 pixels left and right. Now, in reality, if you're making a game, you don't want to use the multiply there. You probably want to do a shift or something like that because, yeah, multiplies are dog slow on the 68,000 especially. So yeah, but yeah, so but it's a kind of a shorthand way for doing these kind of tests, you know. And then basically we limit. We've got 2 if thens to limit the x position so it doesn't go beyond the edges of the bitmap, and then the exact same thing for the y, and that's all. And all that does is move around the bitmap. And yeah, yeah, yes, exactly. For our single cycle multiplies, because it's so important. Yeah, I think I was saying that the other day. For the Solus board, the chip I have on that, it's only a PIC chip. It's a very simple PIC chip, and it's only a 16-bit chip, but it does a single cycle multiply, which is incredible. Like, so I multiply everything everywhere, and it's instead of shifting, it's mad. But yeah, that's it. So what you could do there to speed that up, so instead of doing multiply by speed, so see, the thing is with the speed variable, you can set it to basically any arbitrary speed. So you can set that to 10, and you know, then it'll scroll quicker. So it's 10 pixels per frame. That'll do. You can set it to 1. And yeah, 1 pixel, and so on. But yeah, just to demonstrate, instead of doing it that way, to do a shift. Oh no, actually, what I'm trying to think, if this is going to work for a signed value. But let's see. Yeah, you're doing an arithmetic shift. So ASR is a shift thing. So instead of multiplying by speed, we're going to shift it right by 2. So that'll multiply by 4. So we should get 4 pixels left and right, and then the same for the y. So no, sorry, let's shift left, because you think in a binary number, shifting left is making it bigger, and shifting right is making it smaller. And every time you shift one position left or right, you multiply by 2, and it's much faster for a CPU to do that than to do a multiply. And yeah, it works fine. And there you go. So if you can do things in a multiple of 2, it's much better to do it that way. So 2, 4, 8, 16, 32. Yeah, so if that's not fast enough, then you can do shift left by 3. And then we're doing 8 pixels per frame. Now you'll have to excuse the border on OBS doesn't adjust. Like, you know, the screen, the window I'm looking at is actually adjusted, and that's full screen. It doesn't, without that line at the bottom. It's just yeah, it's just basically OBS being you know, not adjusting to the slightly different resolutions. It does kind of tend to hop around a bit. But yep, there we go. So that is the scrolling. That's, you know, the simplest type of scroll you can get, where you don't actually have to worry about everything. You draw everything onto a single big bitmap and scroll around and just look at a different part of that bitmap. That's all. Yep. Now this is the same thing with smooth scroll. Now this, I think we were talking about this. Were we talking about this the other day? This is the very same code, except we're using quicks for the positions and for the speed. And what a quick is, we covered before. It's sort of fixed point. Yeah. What's your ASL? So basically, it's a sort of a fractional value. It's, despite the name, it is slower to use them for most things, but it does allow fractions in a far quicker way than using a float if there's no FPU involved. If there is an FPU, then use float, but you can't guarantee that, and or you know, if you're making, unless you're making it specifically for an FU, just don't do that. So so this is the same code, except that speed is a fraction. Now what this should be able to do is move in subpixels, use basically subpixel scrolling. Now I've enabled smooth scrolling there. I think when we did this it didn't actually work, but let's have a look now. So now, do we need to set a higher fetch mode or something like that? I can't remember, but smooth scroll is turned on. So as far as I know, that should be all you need. Is flag is 10, hex 10. So that should be all we need for this. But if I remember right, it wasn't moving by fractions of a pixel. Oh, for the love of Jesus. Right. Let's switch to an Rtg mode and see if that fixes the problems. 640 by 512. Oh, I've broken everything now, haven't I? Yeah, bear with me. That's for opening full screen rather than in a window. So let me fix that. Display windowed. Okay, that's fine. Although the resolution isn't great. Oh, horses and courses. Lord Jesus. Let's reboot that and see what happens now. Sorry, folks. Okay, well, at least we can read our font labels now. What? Yeah, let's see. So tutorial 8. If we get some out of memory errors now, I'll just have to switch to using Blitz 2 and grin and bear it with that stuff. So but yeah, the smooth scroll. Been through all that. Let's give it a go. Oh, look, now we're getting our transparent menus. Rtg for the win. Okay, right, that works relatively painlessly. Yeah, that's, you know, one of the joys of Rtg is having having a 24-bit or 32-bit screen. Okay, so we can see there it is actually only moving pixel by pixel, which is mildly annoying because it should be moving quarter of a pixel at a time, and it's not. So I don't really know why that is. I know that WinUAE doesn't 100% support super smooth scrolling, but yeah, I'm not entirely sure what, you know, how, just to what extent it is, and it might just be that it doesn't work there. But if you're on real hardware, you can actually see the you know, the quarter pixel scrolling when you use use fractional values for the display bitmap and for the sprite positions. So you know, then they both accept a quick value, and if you'd send a quick value, the fractional part, it basically rounds it to the nearest quarter, and yeah, and it will display in fractions of a pixel. I think on the y-axis it can only do half a pixel, you know, your interlace resolution, but on the x it does quarter pixel, and you can see it in games like Worms where, you know, you've got your where you've got your, you know, your two playfields, and you can kind of you can actually see where the pixels misalign, you know, like you can, when as one moves over the other, you can see that the borders of the pixels don't match up. Now, question, is subpixel scrolling actually subpixel with a frame of 1, frame 0? No, it is actually subpixel scrolling. And what happens is that AGA outputs a 1280 wide screen at all times, but it just sort of, in a way, emulates a low-res screen by putting in 4 pixels for every low-res pixel. So the pixel clock still runs at the same speed, but just the chips, that, you know, it just fetches the same pixel 4 times, then moves on to the next pixel, then moves on to the next pixel. So all you're doing by smooth scrolling is you're moving the fetch by one 1280 pixel, if you like, and that means that you're moving the entire screen by a fraction of a pixel. And it's the same when you fetch the sprites, that they can be fetched at a 1/4 pixel resolution as well. So it is really nice. It sounds expensive. No, AGA just does it. That's the way it's designed in hardware, so it's essentially free. Although you are dealing with I'm not sure it does actually hammer the bandwidth. The pixel clock is still running at the same speed. All it's doing is it's the DDWI start. I think it's just moving it. It's moving it one clock to the left or to the right. That's all. I know it's only after you move. You know, it's a totally separate register. So what Blitz is doing is, yeah, it just repeats the pixel. That's all it does. So yeah, it's not really fully a 1280 mode that's emulating a low resolution. That's at the output stage of Lisa. So actually, you know, internally you're doing the same thing as you're doing on ECS with the bitmap. Memory usage, no, it's the same memory because you're repeating the same pixel 4 times. All you're doing is moving where the line starts at the very, very left of the screen, which I see now is on the very, very right of your screen. There you go, very, very left of your screen. So yeah, so that's how it works. Now, what Blitz will do is it will use the fractional part of your quick variable and put that into the subpixel thing. Yeah, basically, yeah, it's where the fetch starts and fetch stop. That just moves it by like a 35 nanosecond clock each way. And so once it does that 4 times, once you move it 4 of those clocks, it's 0 again, and then you move a full pixel, and that's it. So it's kind of they do the same on the old Atari 8-bits. It's the same concept. But yeah, that's basically it. So, but you can do very smooth scrolling, and you can do that. It's to do where the actual fetch of those particular bit planes starts, and you can do it separately for both bit planes and dual plane display or dual playfield display as well. It's just not going to show up on the emulation, but you'll see it on real hardware. It will, and it's one of those nice things that's free on AGA, because even if your code is written to do this, if you run it on OCS or ECS, it just ignores the fractional part because that register doesn't exist, so it doesn't matter. Now the only yeah, the only thing to bear in mind is that quick variables themselves are much slower than using word variables. So there is a trade-off there in terms of, especially if it's going to run on an OCS machine with a 68,000. You know, you need 2 fetches to read and write that, or you need 2 full cycles to read and write that value, whereas a word you only need 1. So there is a certain aspect to it that, you know, you might not want to do that, but you know, if you have a little bit of bandwidth to spare, it's nice. Yeah, there you go, and that's probably using the fractional part as well, is it? But yeah, you can't beat the real hardware for this kind of thing. But I think even though it's kind of essentially free in AGA, it's pretty hefty to emulate, because you have to emulate the actual entire thing in 1280 mode rather than 320. And so I'm pretty sure there's something to that Tony Willen said he wasn't going to fully emulate. And I think that's it. Hey, welcome along, Nivrig. Evening. We've just been talking about 1/4 pixel scrolling on AGA, and a little demonstration that doesn't work in emulation. And we've had after the last stream where it was rock solid all night, Amiga Blitz 3 has crashed on me about 5 times, but with an out of memory error. I don't know what it's doing. So I've just switched to an Rtg mode, and hopefully that will solve the issue. We'll give it a go anyway. But yeah, so that is how you would do subpixel scrolling. But yeah, that's kind of like a luxury thing to add at the end. Really, you don't really need to worry about it too much. And you have to bear in mind that if you do that, you want to do the same with your sprites so that they're not kind of jittering out of sync with the rest of the scrolling. You want to keep the fractional. You need to keep, you know, you need to keep everything in sync if you're doing that, basically. So it's the sprites and the bit planes can both be independently set, and you want to do that with both. Okay, smooth scroll. Now let's open it in the next one. What was the next one? Example 3. Dual playfield. Now we're getting to the good stuff. Now let's see if it crashes, because it seems that loading up a new thing causes it to crash. Now we've got one, you know, we've still got the chip RAM available. Ooh, oh, yeah. Oh yeah, I see what I've done here. Right, so 2 bit planes. Got a top one and a bottom one. And you can see it there. There's circles on the rear bit plane and lines on the front bit plane. Now they're controlled by joystick. I am just, you know, I've got a mouse plugged into that port. So, but that's it. You know what you can see there. So let's have a look at that. So we're kind of doing the same thing as before. We're just filling random stuff. But we've got 2 bitmaps, and each one has a depth of 3. Okay, so in dual playfield mode, what you're doing is you're splitting your display into, instead of having 6 bit planes on ECS and 8 bit planes on AGA, you've got 3 plus 3 on ECS and 4 plus 4 on AGA. So this one is an ECS compatible demo, and you see we're doing the same thing. We're setting up 2 bitmaps this time, 640 by 400, and we're doing 3 instead of now on the previous demo we had 5, which is a 32 color screen. ECS does have 6 bit planes and OCS, but you've only got enough color registers for 5. So the last bit plane is only used for extra half bright mode, EHB mode. On AGA you can use that as a normal bit plane because you've got 256 color registers, or you can use it for extra half bright. But here we're just using 2 sets of 3, so that's 8 colors per display, per bitmap. Okay, so use bitmap 2 that's how we select which bitmap we're going to draw to. We're going to draw a load of random lines, and then bitmap 3 random circles. So we create a display, we start our palette, because we've just made a random palette up here with random numbers as well. And now we have set up 2 arrays, and each array is just 2 values. We could do it, alternatively you could do a new type for that. I just use an array for this, and this is the similar code to what we had before. But what we do in the center of the loop, instead of just doing updating the position, we've got 2 positions to update. So we've got the first position for I equals not, which is stored in the 0 element of the array, and we've got the second position was stored in the 1 element of the array. And they're basically doing the same thing. We're just changing that based on what the joystick says. But because it's nice and kind of compact because everything is on 0 and 1. So JoyX0 is the mouse port and JoyX1 is the joystick port. You know, so they're ports 0 and 1 on the Amiga as it stands. Yeah, so everything just kind of lines up that way. But the key thing is on display bitmap here, you can see we're doing 2 sets of, instead of just ending there, which is what we did before, where we have our display ID, which is 0, and then bitmap 2, which is the one full of lines, and then X position and Y position. We're adding on another set of parameters, another bitmap, another X position, another Y position. And if you go to the keyword and press help, you can see that that's up there in square brackets to say it's optional. So we can display a second one. So if you give it 2 sets of parameters, the first one is the front bitmap and the second one is the rear bitmap. And color 0 basically is transparent in the front bitmap. So it doesn't matter what you set it to. What'll happen is everything, basically wherever you've got color 0 in the front bitmap, you'll be able to see the rear bitmap. And so does that make sense? And is that sort of clear enough, or is this actually confusing things having a loop in there. Let's run it again if it holds out. It does. And we can see, yeah, we can see it again there in action. Ooh, look at that. Yes, revision quality demo material right there. But yeah, so does that make sense to everyone? Yeah, cool. Good stuff. And that's basically all there is to doing a dual playfield display. It is. You don't have to redraw anything. You don't have to buffer or unblit anything. It all is just nice. And again, you get that complete separation of the front and rear for free. Now, I will talk about the palette when you're doing dual playfield display. The concept came in with OCS and ECS, of course, and so because that was limited to 8 colors per playfield, they've hardwired OCS and ECS to so that the first bit plane or the first playfield uses colors 0 to 7, and the second playfield uses 8 to 15, and that's it. They're hardwired. You cannot change them. That's it. When AGA came along and they added extra bit planes, for compatibility they kept those numbers intact. So if you open up so basically it means you have like sort of 8 independent colors for each playfield. So if you open an AGA dual playfield display where you've got 16 colors plus 16 colors, so a depth of 4 and front of 4 and back, what happens is the front playfield uses colors 0 to 15, and the rear one still starts at 8. So you've got this overlap, and it uses 8 to 24, 8 to 23. So you've got this overlap from 15 to from 8 to 15, where both those colors are used for both bit planes. Now, that's basically for default. That's by default, so that any software that's written for ECS will still show the same colors that it was made for. But it means that you have to do an extra little bit of jiggery pokery to be able to use completely independent sets of 16 colors. So you can do it, but it gets confusing because, you know, when you make a dual playfield, suddenly an AGA, I can't set separate colors. The tricks are, what you have to do is go to, you have to set the registers, and there's a set of registers. Yes, and the sprites are also hard coded into 8 to 15 in OCS and ECS, and again AGA sets them to that by default as well. So exactly, yeah, you do have those limitations. Now on AGA you can set them, and it basically means you've got these control registers, these display control registers. There's 3 of them, 4 of them, possibly 5 of them, but basically there are 3 of them that are sort of the main ones that you kind of need to adjust, and they have various bits in there that choose where a palette is located in the full span of 256 pens that you have on AGA. So what you can do is you can move the second bit plane display to another batch of 16, so you can have that so that it's colors 16 to 31, and then you can have the sprites from 32 to 48, and there you got sort of 3 sets of 16 independent colors. Yeah, exactly. But see, those rules are there for ECS compatibility. It's not that you're breaking the rules, you just have to basically modify the behavior of the AGA chipset, and that's a known thing. That is how it works. So, and those registers are there deliberately for this feature. It's just yeah, that's basically it. So what we'll do is let's see, I'm gonna have a look at the next example and see what example 4. Oh, so we're getting into sprites now. I don't want to do sprites just yet. So what we'll do is we'll go back to the previous one. Yeah, well, you can do a lot more than that, because as well as that, you can do different things like normally even and odd sprites. Like so, I just realized that I've got I found this humorous T-shirt on. You probably can't see, but it has a bone. That probably makes a bit more sense now. Anyways, yeah, so you can do things like, as well as on OCS, ECS, the sprites, even and odd, always share a set of pens. So 0 and 1 always share pens, 2 and 3 share pens, 4 and 5 share pens, and 6 and 7 share pens. On AGA, you can have all the odd and all the even use 2 separate banks of 16. So that means every single sprite will still be 3 colors, but they can all be a different 3 colors. So you get all of that, and you get, you know, 16 and 16 for dual playfield, or in a single playfield you can have all 256 colors. Things start to get a bit slow and grindy at that point. But we'll go back to example 3, which was the dual playfield display. Yeah. And so, yeah, so what we do to fix that is there is once you've created your display, there's a now see this command, display controls. This sets the these 3 registers: bit plane control, bit 2, 3, and 4. And they are quite key. And this isn't a Blitz thing. This is kind of actual, you know, banging the hardware. You know, it all in all languages, if you like. So, but what you do is you can tie it to a cop list, so it's specific to your cop list. And if you use multiple cop lists, it will only be specific to that one cop list, which is nice. So what internally what Blitz does is it sets up the copper to trigger with those values on this particular display, but not necessarily on other displays. So what you're doing, you're modifying this one display with these properties. Now, bitplane con 2, 3, and 4 there's a lot in there, and it's quite involved, and this is where we get to sort of like pretty low level stuff. So if we look at the help page for that, we can see. Oh yeah, and this is the other thing. Now, this command is slightly buggy compared to what the documentation says. I'll go through that now in a minute. I'm sure one of the examples I have covers this. But so you give it a cop list number, and then you set the values for 2, 3, and 4. Now, what you do is normally you would so it say 0. And then normally you would just say, when you're not modifying something, you just do those. So what it actually does is it exclusive ORs the values in the registers. So that means, in theory, using values of 0 means nothing changes and everything's left at the default values, and it lists the default values there. So the first register, con 2, is 224 in hex. So to change it, you would put your value. Just say you wanted the value, you wanted to turn on bits 1 and 3, bits 0 and 2, and you would exclusive OR that. Oh, exclusive OR is a function. You would exclusive OR that and the default value, which is $224, hex 224. Now, does that make sense what I'm doing there? Now, I've just picked those bits at random. They don't necessarily mean anything. I'll go through the actual meaning of the bits now in a minute. But does it make sense what I'm actually doing there? It's because what's happening is, if you just use that value directly, it will drop the existing values and it'll make a mess of things. So, yeah, it's kind of messy. You know how it works, but you exclusive OR it to the default value, and then that gives you the value that needs to be applied to set those bits. Just basically take it as a given that you have to take the values that are in the help file and exclusive OR them with what you want, and then it'll work. Except for the middle register, for whatever reason, that's pants, and it doesn't do that. Now, I think I'm talking out my arse here. I think it's the other way around. I think you have to do the exclusive OR for the middle register and not for the outside too. bear with me a second. I'm going to try and find some code where I did actually do that. This tutorial 9. Ooh, now we're getting into AGA. Let's see. Uh, 1C20. Now, see, I think I talked about this in the actual article that accompanies this. That's quite a bigger demo now because we're talking AGA stuff. Let's try the non-AGA version. No. Okay, so, okay, yeah, here we go. So you can see here, if you don't want to change anything in that register, you just use 0 and 0. But the middle register, whatever you write, is exactly the value that gets used, but the outside two, you have to exclusive OR it, because what happens is the command itself, display controls, exclusive ORs the register. So what you could do is you could wait for a vertical blank and poke those values in manually. Okay, but you know, that's kind of yeah, it's not ideal. So what we're doing here is so basically we're modifying this. The default value is just C00, and we're setting up this extra bit here, 1C00, and that changes the second playfield palette to start at 16. This is actually what we were talking about. Okay, this is coming into it now. So this is infinite scrolling, but what this is actually doing is loading background. This is loading some files, and it is yeah, just displaying one in front of the other, and it's moving the palette for AGA into the next 16. Okay, so yeah, I know it's a little bit confusing, and I'm sorry about that. But this basically, instead of putting in the default value, which is C00, that's for ECS, we're putting in 1C00, and if we have a look at the what that means is see here, active color bank. Oh, sorry, playfield 2 of 2. Offset playfield 2. So see these two bits here, 11 and 12. Oh, sorry, 3 bits here. They are setting where in the memory or where in the color registers the second playfield gets its colors. Okay, so normally that's set to 1. So what we're doing instead, we're setting it to 2, and that, or normally set to 0, I think, and that is 8 to 15. We're setting it to 1, and that is 16 to 24, or 16 to 31 if you're in AGA. Okay, so unfortunately it is a confusing subject, and sorry about that. But yeah, you can basically that's it. Those three values there are 1 to 8, and they set sort of the offset of where where the second bit plane takes its colors. Now it's not as simple as just adding on 8 each time. Okay, so it doesn't putting a value like those 3. If you take them in isolation, those 3 there are just a number between 0 and 7. Okay, the 3 bits. So just think of them that way. Okay, and the default is 0. That's the ECS default, which gives you colors at 8 to 15. So, but how it actually calculates the position isn't just adding on 8 each time. It's like it's I think it's 8 to the power of that value. Okay, so when it's 1, or when it's 0, or it's basically, yeah, if you set it to 1, it's 16. It's plus it adds on the amount to the power of whatever for the second field. Okay, so if that value between 0 and 7 is 0, 8 to the power of 0 is 1, and that means that it starts at 7 plus 1 was 8. So 8 to the power of 2, it starts at 8. It starts, or 8 to the power of 1 is 8, so it starts 8 after that, and then start 16 after that, or 32 after that, or 64 after that, up to, yeah, up, you know, so you can't set it to, you can only set it to a certain number of different banks, so you have to be careful of that. It is, it's a funky way of doing it. Don't know why they did that, but it is what it is. But it means you can use, like, you know, colors 128 to yeah, whatever it is, 140, 142 as the highest bank for the second playfield. Not that you need to do that, because when you're using dual playfield, you're limited to 16 colors anyway, so it doesn't really make sense to do that, but it is possible. But anyways, it's easy to set that to 1C00, and you can set it to 2C00 or 4C00, whatever you want, basically into that, and that sort of, those 3 bytes there will let you do that. Yeah. Okay, so I'll go through a little bit of extra stuff in here that we can see. So these are playfield priorities. These are basically sprite priorities. That tells you sort of, you know, whether sprites appear in front or behind the playfield graphics. So, you know, you can make it so that sprites appear in front of them all, in front of just the rear and behind the front, or behind both. And that's basically by setting these registers to different combinations, you get the different combinations you want. I'll deal with that some other time. But yeah, so up here we've got basically, and this is what I was saying earlier on, that you can choose different bank of 16 colors for the different sprites, for different sprite channels, so even and odd sprite channels. So you can set that here, like even and odd sprite basically offsets. So you can set them for both even and odd to use basically any portion, any bank of 16 within the 256 colors. So you can see they've got 4 bits each, which means 0 to 15. So that's basically whichever, that basically chooses a bank of 16 within 256 colors for odd and even. So to be ECS compatible, they're both set to 1, which is like 15 to 31. But you can leave them at that, or you can change one, or you can change both and move them around. Now, one thing to note is if you use 15 color sprites, they always use the, oh, I'm going to get this wrong, they always use the even palette, I think. They always use one of them anyway, so you can't change that. So if you're using 15 color sprites, they always use the same bank. You can't separate even and odd because they're combined to make that 15 colors. But yes, I will go and I will talk about sprites at a later time. But basically they're the main things. They're basically the main things you're going to be dealing with there. So sprite resolution you don't really need to change. Border blank, that's an interesting bit, because on ECS and AGA that switches off the drawing on the left and right of this display. So if you're using a copper effect, or if you want the sprites to not be drawn there, that switches off, that, you know, fully blacks out the border. Yeah, it is, and this is the whole reason I wrote my palette ed program, because it's awkward to work out, as well as just being able to combine everything into a single palette easily, and being able to import palettes from different things so that you can get them lined up in the right place in the palette. It also gives you like sort of tool tips as to which bank you're in and stuff like that, you know, so you can tell. But yes, sprite resolution, because sprites can be set to independently they can use independent resolution to the bit planes. You can set like, you know, your bit planes to be low resolution, your sprites to be high resolution if you want, or super high resolution on AGA. and you can set registers there, but you don't really need to do that here. Actually, yeah, it says it there. So anything with an asterisk, you don't need to use the display controls to do that. But what you do need to is to set the Playfield color offset and the Playfield priorities. Pretty sure. Yeah. Oh, sorry. Yeah, and the sprite colors. Yeah, there you go. So, anyways, there is a bit of a crash course in the display controls command. It's a bit of an ugly situation that is in, but yeah, that is it. I'm just going to run this and see if it works. Does it work? Out of memory, of course, you bastard. I think it's time to switch to Blitz Basic. Although it could be, yeah, there could be something else going on there. So let's see. Let's see if this works any better. Articles. Oh yeah. Okay, so that was our scrolling thing. Yeah, so we're going to look at the Blitz tutorial 9, example 1 AGA. Do you? Possibly. A couple of people do. Oh yes, yes you do. A few people do. There are where stuff goes when I've sent things to fix, but but yeah, no. Whenever I get anything sent to me, it goes into a relevant folder. But yeah, there you go. And this is my shared drive because this is on WinUAE. This is my drive that's shared with the host. Okay, so let's see if we can run this tutorial 9 now. You see, and this should still work once we're set up with the right folder. But compiler options, we make sure our the debugger is turned on. Type not found. Okay. Now, let's just see if that works. Oh yeah, for whatever reason, the Blitz 2 debugger is fierce slow under emulation. I don't get it. Oh yeah, this colors look odd, but this was my okay, ignore the colors. I'm not sure what's going on there. And stuck cloud, this is sort of a work in progress thing, but basically this is, oh yeah, no, this hasn't fixed. This is sort of a stepping stone to a future bit of code. But you can see there we've got our two bit planes, or our two playfields, and we've got a couple of sprites involved. So the clouds are sprites, and our walking man, he's a sprite, and you can see that's got sort of 3 layers of parallax, including the little cloud moving by there in subpixel mode. But yeah, there you go. And there's a nice little copper background there as well. I don't know why our little guy isn't colored in right, but this isn't the finished version because you can also go left. But there you go. So that shows you how the display controls thing works. Now, that wasn't the example I thought it was. Yeah, yes, absolutely. But that wasn't the example that I was looking at there. See, this is just being a disaster. Was it this one? No. Which was the one I was doing before? This is the one, right? Okay, so let's see if this works. Okay, so this is the example that I was looking at earlier. So this just swings back and forth. We can see here, we've got our 2-bit planes and independent palettes. So they're both 16 color palettes. Haven't done the copper effect yet, but that runs. I know it probably looks a bit jerky there on real hardware. That's silky smooth, 100%, and it's just repeating the same bitmap over and over again. But it doesn't look too bad, does it? I'm absolutely not going to take credit for those graphics. They're straight out of opengameart.org, which is a great resource. Some of the stuff is not suitable for commercial use, but a lot of the stuff is, and you can just grab assets and change them to Amiga formats very easily, and you know, come up with whatever you need. I don't know why the debugger is so slow in WinUE, but it's just, I think it just it messes with the just in time or whatever it is. There's some reason anyway. But okay, so we can probably pick this apart quite a bit. But yeah, so that shows you the display controls working there. So what all we're doing is, if we take that away, if we take that 1 away, that's the default value. Actually, you know, we'll just comment it out because that's the only thing that is changing. If we comment that out and we compile it, it will look like that. So you can see the front palette has stayed the same, but the rear palette now is half front palette and half rear palette. You know, the blues and stuff, and the blues and greys. So there you go. That's kind of the same thing running on so that just shows you, like, you know, the clash that you get with the shared palette. So yeah, I know this has been a bit messy, but does that make sense to people? Does that make any sense whatsoever? Do you want me to go over display controls in a bit more detail? The thing is with display controls is save your work and experiment with it. And the thing is, you know, there are only so many values. You know, once you know what bits you're trying to get at, by looking at if you look at the help page for it, and it clearly needs some more formatting work. Oh God. Yeah. Anyways, Amiga Blitz 3, it's formatted much better. Alternatively, you can look at the actual, you know, there's lots of documentation on those registers, and it's the same thing. And like, for example, on amigadev.ilawar, whatever it is, basically that's the kind of the official Commodore programming manuals, and that's that gives you all the registers, not the AGA, to be fair. Who has the AGA registers? Code Tapper? Doesn't the Code Tapper website have a full list of the AGA registers and much better explanations of what each of the registers and each of the bits does? But yeah, there are resources out there. You're at a level now where it's not Blitz that you're dealing with, it's the hardware, and you need the hardware documentation to know the right numbers to put into these registers. But yeah, if you need to experiment with them, but you just have to understand that yeah, the values are exclusive ORed. It even says that the default value is given at the top of the parameters exclusive ORed with these, with display controls, so that so to set the sprite color offsets to 1, you need to do $EE. Okay, now if you look at $EE in binary, that'll make a bit more sense, because the last bit is left off. So you're exclusive ORing it, so basically you're swapping the last bit around. Yes, it is very, very messy the way that's done. But even though it says they're all exclusive ORed, the middle one is not exclusive ORed, and you need to poke in when you use display controls. You need to give, if you're not changing anything, if you don't want to change anything, you need to give it the default value, or you'll end up messing up the other parameters that are set. Okay, so yeah, so if you wanted to set something in the first or the third registers, you get rid of that and you do C00, and that's it. But yeah, basically, I think it is Code Tapper's website where you want to go for all those details. We have jumped quite a bit. So what were those questions there? So Super Dan had a question. Is there a way to use that method of scrolling to blit new graphics at the right and clear to the left so you'll have endless scrolling? Yes, and I will. Well, yes, you can do it that way. Like what I have done is I've just created a bitmap that is the same bitmap twice. So when it gets to the end, you just warp around to the next, and that's down here. So basically, for basically this QWrap function is basically it literally wraps the value around. So you get the foreground, like the foreground and background are both the new types, and the X speed, and it just changes. It just yeah, when it gets to there, it just warps back. So this is a pre-prepared bitmap, but you can like doing it like a tile map or doing it some other way is basically going to produce the same thing, So a tile map will let you generate further bitmap from a map, and you can do it that way. But to do if you have a wide enough bitmap, you can just like copy big chunks of it at a time, and there's a scroll command that actually does that. It doesn't scroll the display as you might think, but the scroll is basically used for a big blit. It'll copy it copies a big chunk of the bitmap to somewhere else, and and there is block scroll as well if you want to move in a line section, and it's quicker again, and that's used. You can use that basically like a big blit from one part of the bitmap to another. Yeah, block scroll, exactly. So if you're doing that, block scroll is the way to go because it's much quicker than doing the scroll command. But effectively, that's using the blitter to transfer one section of the bitmap to another. It does consume a lot of blitter time if you do it. So what I would suggest is, if you're creating it, do it in sort of like 16 or 32 pixel wide columns at a time. Yeah, block scroll. It's an interesting because I haven't actually done anything. I don't think I've done anything using it. Oh well, no, I say that like literally scroll command here. So this is how I create this very wide bitmap, is just creating copies of the bitmap going across. If you're doing double buffering, you need to keep the two bitmaps independent. So you see, the thing is, it doesn't really matter if you're doing block scroll. You're going to have to do a second blit anyway. You can't sort of like get the second blit for free by it's not like a copy and paste where you copy to the clipboard and then copy it into two different documents, for example. The block scroll is a source and destination, and the blitter is copying it byte by byte from one to the other. So there's no sort of in-between bit that you can store it and then blit it twice. To do that, you can use get a shape, but that's going to be slower anyway, and you need to have that set up. That's not the way to do it. You would use block scroll basically on each bitmap separately, because you need to have them both independent. Yeah, so you need to do that both. So, and it's the same if you're doing tile map, and we can do a tile map probably now, but to do a tile map, you're blitting sort of tiles as you go, just out of view. So you need to you need to sort of keep on top of that, but you need to do it on both bitmaps if you're doing smooth scrolling, or if you're doing double buffering. Yeah, because you need both bitmaps to be identical basically. I think I'm gonna write so blitz. Yeah, but the thing is, if the blit is fast enough, that's fine. You know what I mean. But how you would generally do it with a tile map is you try and distribute the blitz across as many frames as you can. So let's say your blit, let's say your two screens in two like double buffered infinite scrolling. Yeah. So what you want to do is you want to you want to have a width of a column that you can deal with. Okay, so let's say your tiles are 16 wide. It doesn't have to be tiles; it can be your screen. But what you want to do is, if you're scrolling in 2 pixel steps, that gives you 8 frames before you need those tiles to be available. So if your screen is, let's say, 16 tiles high, you know you need to blitz two tiles per frame to be able to make that deadline of when the screen becomes visible. So you need, if you can do them all in 1 frame, then brilliant. But that's putting a lot of, it means like every 8 frames you've got a spike of demand on your blitter, and you might, max it out and drop a frame there. So, you might have this sort of, and then it'll be jitter as you're scrolling, and you don't want that. So if it's a good idea to spread your blitting out over the whole thing, and that's what, when you're using like you can use scroll to do that, and block scroll as well. So that's that's it. You just think of a chunk, like same situation. If you've got 8, if your thing is 8 wide, divide the height by 8, and then use block scroll on that section, 1/8 of the height of the screen, and do the next frame, do the next 8, the next frame, do the next 8, the next frame, do the next 8, and so on. That's how you do it, and that spreads out the load on the blitter as much as possible. Yes, this is where it gets funny. So not only do you have to do it on 2 bitmaps, but you also have to do it behind you if you want to do full 2-way scrolling. So you do need to keep it. You do need to. So effectively, if you're doing 2-way scrolling with a double buffered, you need to do that 4 times. You need to blit each tile 4 times. Now, yeah, it's doable. It is doable, and it works. Obviously, there are lots of games that use that, but you're spending a fair chunk of your time just setting up the bitmaps as they go by. But yeah, you really, where you've got a high sort of load like that, you really need to be doing blocks rather than blitz. Yeah, that's it. So what we're talking about that now. So do you want to do that kind of scrolling now, or do you want to look at sprites? Yeah, I think probably answered my own question there. I think we'll deal with the infinite scrolling and stuff now. I think that was tutorial 10. No, you're all right. Let me see. Basic tiles. Oh, well, look, I've loaded this one now. Let me see. Example 1. I think it was 3. Let's see, what's this one doing? Horizontal scrolling using tiles. Okay. This is where syntax would be nice. Now, tile map, very obviously a tile map, very obviously ripped off from somewhere else because I did not draw those little trees. But oh yeah, this doesn't do infinite scrolling, it just does scrolling, but it does 2 directions. Yeah, no, that's fair. That's fair. But you can see this is a map that's basically generated randomly. And we should get to the end of it at some point. Are we going to get to the end of it? Or did it just start there? But basically this is redrawing on the fly. As we scroll along, this is drawing out the tiles. Oh, there's the other end of it. Okay, so that's quite a big map. Oh, yeah, and you can hold down fire and it goes much faster. But that is... now, when you say 2 directions, do you mean up, down? You see horizontally and vertically? And the mouse button to exit that. What I'm going to do is I'll load it into AmiBlitz because it's so much nicer to look at the syntax on AmiBlitz. Where was that? Shared. Tutorial 10, wasn't it? Yeah, so Lefty and righty. Okay, yeah. So we'll look at the code here. It looks a lot nicer in Amiga Blitz 3. So we'll look at it here and then compile it in Blitz 2. Oh, I see. Yeah, yeah. So yeah, corkscrew scrolling, for anyone who's unfamiliar with the term, is it's sort of it's an Amiga technique. Like, so what I'm doing with drawing the tiles, that's pretty much a standard kind of basic way of doing it. It works very well, and it would work with little modification on any platform that has that kind of capability. But corkscrew scrolling is a little bit different. That's basically scrolling past the end of a bitmap, and under the assumption that on the Amiga that the bitmap lines up with the bitmap, but 1 pixel down, I think it is. And so basically you're sort of wrapping through memory, and all you do is change a pointer, and you get to be back at the very start of the bitmap again. And it's yeah, it's kind of like it's a side effect of how the Amiga's memory is organized internally, and it works well. But yeah, it's a bit yeah, it's like wrapping around a cylinder, except every time you wrap around it, you move down by 1 pixel. So you just have to bear that in mind. That's why it's called a corkscrew, because it actually, you eventually reach the bottom of your memory if you go for long enough, but you'll be a long time doing that. But just, yeah, it's just it's a nice it is a nice technique. That's one of those Amiga specific things. But let's go through this basically this what we have here. So now we're starting to use constants because our software is starting to get a little bit more, our program listing is starting to get a little bit more complex. So these constants, like, oh, that's weird. So our map is 100 wide and 12 high, and we're using a 16 by 16 tile. So that means we've got 1600 pixels wide and 368 pixels high. Oh, sorry. Total width is... Oh, sorry. The map is 1600 pixels wide and the display is 368 pixels wide. So what we're doing is we've got 320 pixels for the display. That's what we're actually looking at. And then we've got 3 extra columns of width for basically for as scratch area. So there's 1 on either side for scrolling, and we've got 1 in the middle as a buffer. Okay. And so yeah, so that's it. Oh yeah, sorry, no. And what we're doing is we've got 2 either side, and then one as a buffer. 2 extra columns either side, and 1 as a buffer. So that's our actual bitmap size. So we're going 2 screens wide, 320 by 2. So we've got 640 plus 5 times 16, and that's our width. So basically what that does is that gives us 2 columns each side as a scratch area, and then a column in the middle for allowing for overlap in case we miss a frame or something like that. Now instead of making things up, we're actually loading our objects in from disk. So init palette, that sets up a palette object. Okay, 32 colors. So we're loading a second bitmap, and that bitmap is our background. That just contains all our tiles in a row. So this bitmap is 128 pixels by 16 pixels. That looks like, let me see if we can get to it here. And now, whoa. Articles. This tutorial 10. So the tiles look like that. Okay, so basically just different types of grass and trees. And so you've got, like, what is it? 6 times 8 different tiles there. All 16 by 16 with different types of scenery. So we load them into shapes that are numbered 0 to 7. And because each one is just offset by 16, this is a neat little loop. So each time the loop runs around, get a shape command cuts out one block of 16 by 16 and creates a shape with that. Now, oh yeah, so we dealt with blitting in the previous one. Yeah, basically a shape object is kind of just it's just a little bitmap, and you can send that to another bitmap with the blit command or whatever block command. So what we're doing is we're creating shapes numbered 0 to 7 and I times 16. So basically this is your x coordinate of that shape and your y coordinate. So I times 16 is basically going in multiples of 16. Hey! Welcome along, Amiga for Mortals. Thank you very much for the raid. Wow, thank you very much. How was the stream? How was the stream? You were playing Indiana Jones. I saw. How did it go? Way. Thanks for the follow, Anthony. And welcome along, DJC Animations. Oh, you brought the lemmings as well. I know Amiga for Mortals loves the lemmings. But yeah, welcome along. This is going to be a decided change of pace, I think. I can't remember where I got to in Indie. Amiga for Mortals was playing Fate of Indiana Jones there, or Fate of Indiana Jones and the Fate of Atlantis, and I don't remember where I got to when I played that back in the day. But oh no, did you miss out? Did you? Oh, that's unfortunate. Welcome along, Garth Qualley. Yeah, that's annoying if you missed out on saving it. We'll give you a shout out there. But yes, Amiga for Mortals was playing. Oh, there we go. Indiana Jones, and I don't know where I got to it, but I must check out where you are, because at some point I was yes, exactly, can't brain at the moment. Thank you for the follow, and welcome along all the new viewers. If you haven't watched me before, I'm Rob. I normally do all sorts of weird things, usually Amiga related. A lot of games, sort of slightly, some unusual games like from late in the Amiga life, or I was doing a playthrough of Settlers, a bit of A-Train. Sometimes do Atari 8-bit stuff as well. But there is a Blitz Basic game jam coming up in a few weeks. So anyone who has any kind of itch for a bit of programming, please get interested in that. There we go, Super Dan with the jam shout out there. Join up and have a go at making a game. Team up with people, make a game. Doesn't have to be a particularly fancy game. A lot of the best games are pretty simple games. And so this is what I'm trying to do, is trying to get people kind of kickstarted into a bit of Blitz, especially if they've, if you've done a bit of programming before but never on the Amiga or never on Blitz. This is sort of like a kind of a an introduction to Blitz in that way. And once I'm hoping to get people set up to a point where they can move graphics around the screen, draw their own graphics, play some sound effects, and then you're on your own. You know what I mean? Once you've got that there, everything else is just sort of the logic behind it, and that's kind of yeah, that's whatever you can come up with yourself. Thanks for the follow, Nally Pally, and welcome along. Yes, this is JC1980. This is Ami Blitz 3. So Blitz Basic got as far as 2.1, and that got a load of updates, and then it kind of went by the wayside and got open sourced. So what happened is that became Ami Blitz, and that has been updated significantly since then. Now, this is a really nice editor, nice syntax editing, and the language itself has a lot of updates as well, minor updates, but a lot of sort of quality of life things and a lot of fixes. But at this point, yeah, I'm trying to, basically I'm using Ami Blitz because it was crashing on me something serious earlier. My previous stream, it was absolutely rock solid for about 4 hours. Don't know, I was having a bad day today. But anyways, yes, it is a very nice editor compared to the original. And yes, thank you, Zuperdan. Yes, they are on. I have them on my YouTube channel. I have them. They are on my Twitch channel as well. And you know, I think on Twitch they last for about a month, and then they disappear. So I'm transferring them to YouTube as well as they go. Do I have a YouTube command set up? I don't know if I do. Let me just throw the link in the chat. But yes, this is let me see, where is my thing? Come on, YouTube, you can do it. You can do it. Okay, so I've set up a playlist that contains all my Blitz tutorials, and that is, whoa, there. Let's see if I get banned from my own channel for posting links. Nope, excellent, it worked. So thanks very much. Yes, this has come up a few times. There are ways of doing it. JC, there are ways of doing it in that people now have complete like sort of like hybrid setups where they develop in Windows and basically use AREX and some sort of voodoo in the background to transfer the code into the Blitz environment where it gets compiled and executed. And so, you know, that is an option, and there are quite a few people doing that. So if you like, there is a Discord for the Blitz Basic Game Jam, and there are a few resources on there, and there are a few people doing that. I'm pretty old school, and I'm going to be doing it in, when I say old school, in this editor, which is only like a year or two old. But AmiBlitz does support CLI arguments for compiling as well. It does do that indeed. But you kind of miss out on some of the nicer, well, I say nicer aspects, like the AmiBlitz 3 adds kind of some pretty nice things with the definition browser, library browser, and stuff like that. So thanks for that, Nivrig. It's yeah. So I like the environment actually as it happens. So I'll be doing it because I kind of yeah, a bit old school, but it's part of my charm is to use like the Amiga from the ground up, I suppose. That's what it does for me. Other people aren't so interested in that kind of pain. And fine, absolutely fine. But yeah, there are a couple of big cross dev setups that use that kind of thing, and people have created language files for Notepad++ and I think for the Atom editor and a couple of others. So you know, there are options now that weren't there, you know, 20 years ago. So it's definitely worth checking out, and sign up for the Game Jam and give us a game. Thanks for the follow. Spike was here. Thanks very much. Oh yeah, because it is Visual Studio Code that I think is the main one that people use. Definitely worth checking out. Now, let me see, what were we talking about here? So we have a kind of a fancy, actually I'll show you now. So this is AmiBlitz 3. It does like a bigger screen mode, and I tend to use it on Rtg, so I get a much higher resolution. But I've bumped it right down for the purpose of the stream because you'd never be able to read the text. But that is Blitz 2, the very same code in Blitz 2. So you can see it definitely doesn't have the same feel to it, and it's harder to spot the syntax because it doesn't have the syntax highlighting. But this isn't crashing, and AmiBlitz 3 was crashing, so that's why I've loaded it up here as well. Now what we have here is basically we're looking at doing a tile map, and I'm working through that setting up a tile map to scroll that, you know. So yeah, I basically, when AmiBlitz 3 first came out, I moved on to that, and yeah, I never looked back. I'm kind of like, fine, I can use it. I can use Blitz 2 if I need to, and the editor. But yeah, once I got the AmiBlitz 3 editor, I was like, this is the way it should be. But anyways, that's besides the point. So this code makes a pretty little map. It's essentially a semi-random map where it fills the map with tiles and to a certain pattern. And let's see what it looks like, see if it runs again. Now, under emulation, the debugger is very slow for whatever reason. But yeah, so it makes a map that looks like that, you see, and we can scroll left and right. And basically it's some random tiles in there, and then it gives a pattern of kind of trees and bushes along the edges. So gives you an idea of what you call edit foundation and TED. Yes. Well, you can split up the code into different include files, like like you can in C, and then it kind of it adds them all together at compile time, and so that's an option. I do that as well, because when your code gets too big, it's just messy. But yeah, oh yeah. So the Atmail AVR stuff. Sorry, I'm just going back there. Yeah, it's a while since I did Atmail stuff. I do microchip stuff in the MP lab, and I think, is that based in Eclipse? I can't remember what they use as a base for that, but it's quite, they've modified it quite a bit to support their environment. But it is a nice editor. But yeah, they're like any modern editor is obviously like leaps and bounds ahead of what we have here with Blitz, but fair enough. I love pick chips, and my old job I used pick chips and I used AVR stuff. I use Atmail 80 megas. I like them both, and they both have their pros and cons, but I do like them. That's kind of my thing, that kind of environment. But sadly don't use them anymore, or don't do them for work anymore. But there you go. Anyways, yeah, so look, we can scroll across here. We've made up a map. This is a bitmap that is, or it's a map that's far wider than we could possibly support by having a single bitmap big enough. So what we're doing is we're blitting blocks to the side. So we can scroll, and we've got a bitmap that's twice as wide as the display plus an extra bit, and we are blitting into the extra bit as we go and as we need to. Yeah, I do pretty much all my big programming in C, but yeah, I haven't gone into either of them that deeply to see limitations in the support. And to be honest, that's why I've used Blitz for a lot of things, even though, so I'm doing that kind of stuff. I was doing that kind of stuff in work, and then I come home and I can do completely different stuff in Blitz, and it is refreshing. I like that. Yeah. Oh, thanks for the follow, DJC Animation. Thank you. Yeah, there are a couple of pretty serious tricks. I'm trying to keep things to the fairly basic techniques at the moment. So I know the corkscrew scrolling was mentioned earlier, which is a nice way of doing it. But to have two-direction scrolling, the simplest way that I know of, without going into any crazy tricks, is to have a bitmap that's twice as wide as the display. So what you have is you have the bitmap and you have another copy of it there, so that when you scroll backwards, it's kind of, it's in the right place, and as you scroll, you're blitting basically in the right way. Yeah, no, there are, and there's a famous archive on AmiNet that has it has a load of different tricks. It had like 6 or 7 different techniques, and the 8-way scrolling where and there are some really nice tricks that properly hammer the hardware, and that's kind of like proper, that's what the Amiga's made for kind of stuff, But yeah, so I'm keeping things simple so that it's like people can at least follow it and might come up with something rather than basically spending a month not getting a really tight routine working and then just giving up. So that's the plan here. But yeah, so that's we can see there, and we're scrolling, and what we are doing is we've got 2 copies of it, and as we scroll to one side, we are blitting a row of tiles behind us that is the correct kind of position for if we want to change directions. And yeah, hey. A group of Italians giving me the 100 bits. Thank you very much for that. What happened there? Oh, I must switch that off. Nivrig, you know what? I think you should be a mod. Okay, go for it, Nivrig. Yeah, so just hold on a second there. You should be a mod there now anyway, Nivrig, so you know, go nuts. Yeah, there are okay, cool. Well, thanks for dropping in. Thanks very much for the raid, and yeah, no, it's really appreciate having you here. And do you know what? Get involved in the jam. You've still got a month to get ready, because it doesn't actually start, or well, I would say a month. You've got 2 weeks. It doesn't start until the 1st of June. Yeah, exactly. Now it's your own fault, Nivrig. Yeah, that's exactly the scrolling trick. That is it, and it's actually like a collection of 6 or 8 different tricks, and full working demos of them, and they're fantastic. So they're well worth a look. But yeah, I was going to say a group of Italians there. That is a friend of mine from work, from my day job, who has nothing to do with the Amiga or programming at all. But really appreciate the support and being here and all that kind of stuff. Thanks very much. Yeah, good night. Good night, Amiga for Mortals. Now, so scrolling, what were we doing? Yes, so yes, copy of the bitmap, and we're blitting basically into, no, you've come along to a couple of my games nights and brought beers, and, you know, so that's what counts. We'll have another one of them soon, don't you worry. But yeah, did you come along actually? Well, you're definitely due to one, for coming along to one soon anyway. Anyways, yes, right, so what were we talking about? Let's get out of here and go back to the code. Now, far easier to read it in when we've got our syntax highlighting here. So we've set up our cop list, just a normal cop list. How, you know, the flags variable here, right, is just for ease of reading. $10 for hey, welcome along. Yeah, it is, isn't it? Yeah. I like the way you're being different. Absolutely. Yes. So this is setting up our cop list for smooth scrolling and for 5-bit planes deep. So we're like, you know, we're opening up a 32-bit screen, or 32 color screen, 32-bit screen. Yeah, yeah, so we're setting that up there, 32 colors, and then we're displaying that, and it's as simple as that. So we're displaying our bitmap. So here we have the block command, and we see we're after drawing the first set of our map across the way, and this loop. This is just a nested loop that starts instead of using the blit command, uses block, because block is much faster because it works in multiples of 16. So you can see there, it just blits those map elements to the positions in multiples of 16 there. You see, and I'm multiplying by 16. You can do a shift there as well to save time, but yeah, that's fine. It makes it easier to read, I suppose, if we're doing it that way. Now, what I should point out before that is this is how we're actually creating the map. We're just making a map of bytes, simple as that, and it's a 2-dimensional array. So it is map width by map height. Yeah, you don't get any transparency with block, but it's good for this kind of thing where you're just drawing tiles, you know. So we are just putting random numbers in between 0 and 4, and then for once in a while we'll just put a like, you know, sort of a, or if it's an edge, we'll add 4 onto that, and that gives us sort of a separate type of drawing. But yeah, so that's it. So it's as simple as that, and then we're just adding this little effect here, which is modulus. And modulus, basically, for anyone who doesn't understand it, the simplest way of describing it is it's your leftovers when you divide by a number. So so basically this is taking the like, you know, it's sort of set, this makes steps. So this will count up to the 12 and then start back at 0, or 11 and start back at 0, you see. So it divides by 12, and that's your leftovers. Yeah, so yeah, there obviously there are ways, there are reasons for it and for not it, but what we're doing here, we're not dealing with any of that kind of stuff. This is simply, now I know we're talking about cookie cuts and stuff like that. We do actually have a cookie for this, because Blitz automatically creates a cookie when you get a shape like that. Not anything to worry about too much. But yes, and that is right. The top play field will be transparent on color 0 anyway. Okay, so that's what we're doing. We've set up our map, and our map is just a list, like I said, it's an XY, it's a two-dimensional array of numbers, and each number corresponds to a tile. So we've already loaded up those tiles, those shapes, number 0 to 7 up here, and that's it. Now, in a cop list, that's fine, and yeah, we were down here where we display, and we've got a coordinate variable here, bmap x. That's our x point on our bitmap. So so that is not the, oh sorry, so what we're doing is our display width is a number we defined up at the top. It is 368, because we've got it's 320 plus 3 sets of tiles, and so basically our x position, that is our position all the way across the map, 1000 pixels wide, or 1600 pixels wide, whatever it is. That's our position in the world, if you like. But what we're displaying is actually bmap x, and that is how far we are across our work area. Yeah, exactly. Block is a whole lot faster than using Blitz because of that, exactly. And it's the same with block scroll. The command block scroll copy is the same principle. It just copies from the bitmap instead of from a shape. And then tile Y is basically, yeah, doing a similar thing. So what we're doing here is we're changing the speed variable based on whether the fire button is pressed as well, and that's how we're getting the fast and slow scrolling there. Simple as that. So if there's a joystick button pressed, then the speed is 5, otherwise speed is 1. And that's it. So now we're doing some shifting to save speed, or to save time. So basically, tile Y, we can see here, that's a mod of the tile size. So basically this is taking our X position, and we're going in multiples of 16. So tile Y is basically a variable that goes from 0 to 16 as we work our way across the map. Okay. Now, so what we're doing here, it's this loop. So ignore the loop for the moment. So this is so tile Y is up to 16. Now our map is only 11 tiles high. I think it's 11 or 12 tiles high, right? But we are going basically 16, because what we have is, remember I was saying earlier, so as you're scrolling across, we can scroll 16 pixels before we run out of drawn screen, because our tiles are 16 wide. So we've got, outside the end of our display, we've got one extra row of 16 tiles that's drawn. Okay, so we can scroll just by moving the bitmap and doing nothing else. We can move a maximum of 16 pixels. So the tile Y, as we move across the map, the tile Y variable is counting up those, is basically a sort of a set of those 16s. And what that means is that's synchronized with our movement. And what we're doing is we are using that variable to choose whether we want to draw beyond that what we can see or not. So or what we want to draw. So basically we're saying if we're less than the map height, so the map is only 11 tiles high. So basically as we're scrolling for the first 11 of these 16 steps, it will draw a new tile. And that we can see here we're basically dividing by 16 our position to get the tile number, but we're doing that with a shift. So LSR is a logical shift right. That just basically takes your binary number, shifts it, and anything that sort of falls off the end falls off the end. So it does a sort of a, not a rounding, you just lose your decimal section of the number altogether. And so basically that just gives us the sort of the number where our tile starts. So like it'll be tile tile 0 is the first 16 pixels, tile 1 is the second 16 pixels, and so on. So does that make sense? Yeah. So so all right, well the video will be there anyway. Yeah, so if that makes sense, then great. So then what we do is we then what we do is we draw, basically if we haven't gone far enough across the map, and we use block. Oh, yeah, the color is slightly funky when you scroll left and right on this. We're using block to basically draw the tiles we need from the map and put them on the bitmap. So again, we can use block because we don't have to be sort of, you know, to a pixel. We're doing multiples of 16. We can use block everywhere here, and the same with block scroll. And it's not visible, so it doesn't really matter. Well, it's not visible at the moment. So yeah, so that's basically it. We map X is like, okay, that's our position across, but that'll only get up to 80 instead of instead of 100. You know, our map is 100 tiles wide, but yeah, that's it. That's what the modulo is. But basically, yeah, our map is 100 tiles wide, but we're only interested in moving as far as tile 79 because our screen is 20 tiles wide. So that basically will be as far as the scroll will go. It won't go any further than that because then we'll be showing rubbish, or most likely the rear end of that bit plane, or you know, it's something, there'll be something funky going on beyond that. Here be monsters. So we don't do that. We won't scroll past the end of the bitmap. And obviously if we reach the end there, we don't need to draw anything beyond that anyway. But yeah, so if we're in the right place, we will draw basically the tile that we need. And we're drawing that at sort of basically map X plus 21. So that's 20 is our screen width, 21 is the next row beyond where we are. And that's basically it. So that's kind of how we well, that is how we just you know, we draw sort of, we distribute our blitz over the full scroll as much as we can. Because the tiles are 16 16, we only have 11 tiles high. Some frames we don't do a blit. That's fine. So, but that's, oh yeah, sorry, I forgot to say this section here. So if the tile X is greater than 1, we are blitting behind ourselves. So we blit a point -2. So basically we're looking at 2 rows behind, because one row behind we can still see a part of that column. So we don't want to draw on that. So we want to go, at least we want to skip that row and draw the next row behind us, and that's so our X position -2. And that is yeah, so that's drawing the same map behind us, or the right, that's drawing the correct kind of tiles behind us as we go, so that we can scroll backwards when we need to as well. Okay. So that is, yeah, that's basically it. Oh no, sorry, I'm after mixing that up now. sorry, I should say that we are multiplying the position by 16 here as well. Oh, one of those nights. Yeah, so this is our tile number, and we're multiplying that by 16 as well. You know what? I will upload a load of these to the either the Discord, or I'll find somewhere to put them, because yeah, this is something you kind of need to work through, and yeah, it's probably a bit tricky otherwise. But yeah, I'll upload these and put a link somewhere afterwards. Good point. Because the other stuff is kind of pretty much you can do, but this is yes, starting to get a bit deeper in. Ha, okay, the same question twice. This is excellent questions. ASL and LSL, one's with arithmetic shift left and right, and the other is logical shift left and right. So one takes into account the very, very leftmost bit, which is your sign. Okay, so basically, if you've got a negative number or a positive number, that basically the very last bit on the left is your sign. And so if you shift left and right, that sign loses its meaning, because if you do a logical shift left, that loses its meaning because you've moved that bit away from the position where it means positive or negative, and now it just means 128, you know, or whatever. So you basically an arithmetic will use that. We'll basically take that into account when you're doing the shift, so you don't need to worry about if it's a positive or negative number. It will stay positive and negative. So if you've got an 8-bit number, it will do a 7-bit shift on the rightmost 7 bits. Okay. Now in Blitz there are no unsigned values, so all variables are created with a signed kind of with a signed they are all variables are created signed. So you can't have an unsigned value in Blitz unless you kind of do all the binary stuff yourself. It's messy. So exactly, that's basically it. Yeah, some variables are more signed than others. Yes. Like I mean, you can if you kind of avoid doing anything that kind of will cause a sign shift or a sign conversion on it, then yeah, you can treat an 8-bit number like an 8-bit number. Like, you know, if you use hex, for example, or binary notation, it is what it is. You know, it's a binary number. But yeah, basically that's the difference. For us here, it makes no difference whether you use LSL or ASL. It doesn't make a difference. But yes, if your numbers are going to be negative, and I used ASL earlier because of that. Yes, yeah, that's the internals of it. Yeah, so basically it's kind of down to whether you want to be able to preserve the negative or not. Now, yeah, JC's talking about 2's complement there, and exactly, yeah. So how negative numbers work is basically that, yeah, your leftmost bit does denote negative, but it sort of wraps around the value. So it's kind of what happens when you've got a byte, for example, and you have 127 in it. When you add 1 to that, it becomes minus 128, and that's because it overflows into the basically overflows into the 8th bit. But yes, that's 2's complement, and that's it's a special way that CPUs deal with representing negative numbers. It's basically, yeah, that's have a look at that. But in simple terms, if you want to preserve the minus, then you use an ASL, and if you don't, then LSL. That's basically it. But yeah, for what we're doing here, we're talking about multiplying small numbers by 16. We're never going to get big enough that it makes a difference. So, you know, I'm more used to doing like an LSL with like you say with like, you know, with your shifts in C. So that's just kind of how it translates in my mind. But anyways, yes. So basically, we are sorry. That's a good question. I'm sure. You see, you can do all that you can do all the assembler stuff in Blitz anyway. So you can do something like yeah. It just works. So now so direct value and then address a register. Yeah, you can. You can do that in line. So it doesn't have its own specific command. And you know what? LSOR is probably not even a Blitz command. It's like a Blitz pass through to assembly command. So yeah. But anyways, yeah. Sorry, I made a bit of a mess of describing this earlier. So what's happening is, instead of drawing the map as it should be behind us, we're drawing an exact copy of the map that we're drawing ahead behind us. And what that's doing is, that is update, you know, I said we have 2 copies of the bitmap, so sort of like 2 copies of our image, one on each side of the bitmap. What the first line here, because we're scrolling right at this moment, the first line here is drawing ahead of where we're looking, and it's drawing over there. But the second one is drawing 2 columns behind the back of what we can see, and it's drawing the same tiles. So even though it's the tile that should be appearing in front, we're drawing it at the back as well as at the front. And the reason for that is, when we run out of space in our bitmap, we will have another copy of where we are at the front of the bitmap, and we can just instantly flip to the first half of the bitmap, and it looks as though nothing's happened. Okay, so that's why it's important to be redrawing the exact same map behind us. Okay. Now, sorry, I've confused people by saying this was drawing the scroll left part, but no, don't worry about that. We only do that when we scroll left. Okay, now, sorry about the confusion there. Does that make sense to people now? Yeah, sorry. Yeah, I confused myself. Okay, so that is it. But now, you can see that this is in a loop. And the reason that we're doing this in a loop, it doesn't really make much of a difference, but we have to blit those tiles anyway. So if we're going to jump 5 pixels ahead, yeah. And you know what? When this is a demo that I wrote for Amiga Future magazine a few years ago, and I drew up a sort of a set of grids, and I tried my best to illustrate that. But yeah, it's one of these things you kind of have to draw it out, and then yeah, do it on some graph paper. Have I said graph paper since I was in college? Don't know. But yeah, do it on some squared paper, on some grid paper. Write down even numbers, like example numbers of saying this is my screen position plus 16 at the top of the column, and so and that helps. You know, that is exactly how I do it, and I still do it all the time. It is complicated to explain it in an abstract way. But yeah, so let me just see if I have that. Tiles.png, does that work? Oh no, that's just the same one. Let me see. Tile scrolling now. This might be too big for my poor little Amiga to do. No, that's a screen grab. Scrolling. I thought I did have it. Oh, there it is. It's a PostScript file, so I can't display that on this. I'll upload that, and we can have a look at that at some point. But anyways, yes, that is the easiest way to do it, is to draw it out yourself. But yes, now the reason we're doing it in a loop, as I was saying, is because if our speed is anything other than 1 pixel, if we jump 5 pixels ahead, we need to make sure that we blit those 5 tiles that we would normally blit in that if we did it sort of 5 pixels one at a time, if you know what I mean. So we have to do it 5 times. So basically we're going to be doing the same thing anyway, so you might as well just put it in a loop and do that for as many times as we have to. So it might seem a little bit inefficient to do that because we're kind of doing a few calculations extra, but by far and away the largest time sink in there is the blitting. So everything else is kind of like, yeah, it doesn't really matter. Yeah. So, and yet then we see the last thing we do at the end of each loop is to update our X position. And And yeah, and we go, if we go to the total, if we get to the end, we just don't go any further. You see? So if it's the furthest we can go is the total width of the bit of our world minus 320 pixels, because that's our screen width, then the X position stays there. So we don't add to it anymore. You can do that another way, so by saying if X position less than that, then add one. It's probably marginally more efficient, but yeah, it's not a big deal. Now, and now we do the exact same thing in the other direction. Simple as that. So I can go through it again and say basically we subtract one from our X position each time, and then yeah, we're doing the same calculations, but this is just because we're scrolling left, and we draw at a position behind, like to the left of us. We're drawing what's coming up, and then we do the same again. We create a trail behind us, just out of view of the screen, of the tiles we're blitting. So we're blitting the same on both sides, and that's carried on across both of them. So that that is it. But does like, now I know that's a bit messy. Any questions on that? I'll just load it up again. Makes sense, I think. Yeah, like I said, it is yeah. no, I'm not starting from the start. I'm going shite. Confused myself enough with it, but yeah. So you can see there, anyways. We've got yeah, all the way back and forth. There you go. Oh dear. Yeah. Yeah, worth a try, Cream. But anyways, right, so there we go. That can essentially give you infinite scrolling. It's not the most efficient way, like as JC was saying earlier. There are more extreme techniques you can do to wrap around very tightly and get it into a like literally only having another 32 pixels on the width of your bitmap or something like that. But that's being, yeah, that you really need to be stuck for a chip RAM, and I don't think it's worth for you know, for casually playing with something, you know, and getting to grips with it. I don't think it's worth going into that kind of level in Blitz. That's a pretty hardcore stuff. So this is kind of like, you could call this the kind of the logical way of doing it. Everything's sort of out, you know, everything's visible. If you save that bitmap at each stage of the way, you can see what's actually going on, and it's quite logical how it works. Yeah. You get to you kind of get to lose a run of yourself. So yeah, so when you're dealing with this, you do also have to remember where your X value is, because it's when you blit, you're not blitting in the world. So if you in the world, you can be 1,000 pixels across here, and you know, an enemy might be 1,020 pixels across, but you don't want to blit there because you want to blit on the actual on the map, or on the bitmap. And that is, but basically all you have to do is subtract the X position from there, and then it's done. And the thing is, like, you can do a full 8-way scrolling on this by doing basically the same thing, but in the Y direction. So you do end up with a lot of blitz if you're going diagonally. That's, you know, it's unavoidable basically. But what a nice technique is to do sort of like you know, do infinite scrolling in the X direction, for example, and then do sort of partial scrolling in the Y direction, or vice versa. Like, you see some shooters where you can, I think Banshee does it, doesn't it? That you can scroll a certain amount left and right, but that's just like a single wide bitmap. There's no extra drawing going on there in the background. So, but you do get an extra bit of width, and it's an extra feeling of, you know, space, and then your infinite scrolling is in the Y direction. But you can do tile scrolling, infinite scrolling in all 8 directions easily, or relatively easily. You just do the same thing in the Y thing. in the Y direction. You will end up with large bitmaps. Yeah, but it's still only going to be yeah, relatively big. You know, or relatively small compared to you know, compared to the amount of chip RAM you have, especially if you're only doing 16 colors or something like that, or even 8 colors if you're doing a dual Playfield. Yeah. It is slightly more. There are a few different ways of doing it, and that is slightly more involved to do it that way as well. But yeah, if you scroll upwards, you'll see that there's a sort of a bit of a gap of garbage, and then, like, if I was to scroll this upwards now, you see there's a bit of garbage and then the same bitmap again. But you can, yeah, you can harness that to give you some nice yeah, some extra space. But yeah, you can do it. This is kind of like, I would almost think of this as like, it's not system friendly, but the system friendly way of doing it. Everything's kind of above board. No, there is a vertical wrap, because, you know, no matter what you do, you're going to run out of bitmap space, so you have to. You know, there's only a limit to what you can sort of display on screen without sort of running out of room to basically draw what's coming up. So yeah, you do have to jump around the bitmap, but it's yeah, you can do it sort of. You know, you can minimize that, or you can harness the kind of that, so long as you don't run out of your chip RAM. You know, like I'm saying, you can end up sort of increasing pointers and going all the way down, and you eventually fall out the bottom of your memory, and then all hell breaks loose. That's going to be a bad day. But anyways, yes. So that is that. Any other questions on that? And I was going to do sprites now. Yeah, exactly. Yeah, basically you want to give yourself upper and lower limits of what you're doing, and not go past them. And because yeah, it's just going to be bad news for everyone. You know, shit all over your game logic, or shit all over your operating system. You don't, you know, even worse. You know, corrupt your SCSI.device or something like that. Anyways, I'm going to take a quick break and see if there are any snacks around to be had, and I'll be back in a second. What did I miss? Oh, let's see what's going on here. Let's see, what was that question? I missed a question there. Oh yeah, hydrate and refuel, exactly. And refueling on these, saw these in the supermarket earlier and thought, oh yeah, I don't have enough salt in my life. So flame grilled steak flavored peanuts, and they are a 30-gram serving is 12% of my saturates, 21% of my fat for the day. Oh well. No. Well, first off, no, Blitz doesn't auto clip. So if you, yeah, I'm in real danger of consuming about 6 portions here. So there's no clipping. It does have a clip blit command, but it's much slower. Yeah, basically what it does is it does a check in the area, and then blits from the shape only this section that will fit, and puts that in the bitmap. So if you're in danger of blitting, I would what I've done in the past is just make the bitmap a bit wider by the width of your largest shape, and then you can blit right to the side of it, and it's twice as quick because you're not double blitting everything, and you know, cost you a bit of memory, but that's it. Oh, they're tasty. Oh, I have to put them away. So what else did I need? Yeah, the thing is, Fryer 85 is if you, yeah, Blitz while you're running it with the debugger will catch that, and it will say you're blitting outside the bitmap, and it'll dump you back to the editor. But once you actually make an executable, you don't have the debugger there to catch that, and it will just blit wherever you tell it to, like wherever you tell it to in memory. Yeah, so the debugger, sorry, I should have said that. The debugger will check every blit to make sure it fits. And if it doesn't, you get an error, but yeah, that's it. Spike was here. What's this? You can move it by waiting for the vertical scan. Yeah. Well, yeah. There are various different ways of doing it, and some of them are kind of like I have to sit down and draw them out on paper again to figure out exactly what's going on. I'm not going to cover them because I think we're just getting too much into it for this tutorial. Oh man, I'm going to eat all of them. I don't think Blitz does handle a wraparound. Blitz is kind of you know, in many ways it is actually sort of like a quite low level in how it deals with Amiga stuff. So you know, all the see, you can see the syntax there that that AmiBlitz does. Any of those commands that are sort of in the purpley color, they are banging the hardware directly, and they just you know, they just, you know, literally accessing the registers that need to be done and throwing pointers around in the chipset. They're going to make a mess of things if you don't treat them with respect, and they don't have a kind of an operating system fallback. They're directly banging the hardware. So you know, so if you want to blit into it, you know, it's kind of nicely wrapped up because, you know, you have to have a currently used bitmap. But if you don't have a currently used bitmap, the pointer for the current bitmap, it's just like random garbage. And if you blit to that with the debugger will tell you, no, you can't do that, there's no bitmap. If you don't have the debugger running, like if it's an executable, it will just blit it into some random bit of chip RAM and your whole machine shuts down, like, because, yeah. So, you don't want to do that. If you did split across a wraparound like that, yeah, that's the standard workbench one, screensaver, yeah. But if you do split across the gap like that, you need your bitmaps to be aligned on a 16 pixel boundary as well, I think. Oh, for that to work, I'm pretty sure. Okay. Cool. Well, the thing is, yeah, if other people want to cover stuff, by all means, you know, definitely in the Discord, it would be interesting to see if there are other people have other scrolling techniques that work and can save a bit of chip RAM. But it's, yeah, I've experimented with them and like it's fine, it works. But yeah, I have to sit down with paper and struggle to figure them out myself. Yeah, but that's kind of what I'm saying here. This is kind of what I'm doing here. No, you're all right. Don't worry. I'm all for the discussion here. You know, it's all fairly casual and stuff. But yeah, yeah, exactly. And that link that Nivri posted earlier with the, you know, the scroll trick or whatever it's called. I think it's funny that it has a singular name because there's about 6 different tricks in there. And they all work in their own way and they all do their own thing. And it's fantastic. They're fantastic, you know. Okay, so anyways, shall we look at some sprites? I can't remember what I have to do with sprites. And then I probably have to call it soon enough. Sorry, we loaded up here. Yeah. What was example 2 in that actually? Sprite collision detection. Have we not done sprites yet? Do we have to go back to tutorial 9? Oh yeah, that was what we had before. Okay, right. Well, this is our wizard sprite thing. Let me see if this is going to work with what we have. Example 4. See if it works. Oh yeah. Well, okay. Colors are nearly right. Something's slightly odd with the color of the cloud there, but yeah. So this is our. We saw it earlier. We had our dual Playfield display. 16 colors for the background, where the mountains are. 16 colors for the foreground, where the trees and the grass are. And 16 colors for our sprites. Now, the cloud and the wizard are sprites. Oh, sorry, yeah. Yes, I was using the scroll wheel, yeah. Scroll wheel works fine in, well, in most things because I have a freewheel running. But yeah, so basically we've got our nice little animation here, and that's a sprite. And basically that's it. Now, This isn't doing any tile drawing or anything like that, but you can do tile drawing. You know, there's no, it makes no difference here. But yes, it is. This is an AGA thing, and yeah, with exactly the same amount of safety. Yes. You know, if you want to yeah, if you want to shit in your neighbour's lawn, absolutely go ahead. Take these nuts away. Anyways, so you can see here that I don't know why the cloud colors are funny, and the wizard color was funny earlier as well. But yeah, that wizard's nice big sprite, and actually you can see the pixels in it. A lot of the pixels in that wizard are double pixels because it was they're from kind of like, you know, retro style game again on Open Game Art. So some of the details are 1 pixel, some of them are blocky pixels. So it's actually got a kind of a funny look to it. But you may or may not have noticed that the cloud goes behind the tree. What? But the wizard goes in front of the tree. Yeah. Yeah, they are AGA, so they're nice wide sprites, and they are 15 colors, or at least the wizard is 15 colors. The cloud is 3 colors. But yes, so the one of the nice advantages, one of the nice things with AGA, like, you know, they're people kind of I don't know. I like the AGA chipset. I think people don't give it as much credit as it's due, really. But one of the things they added with it was that you can have sprites that are 4 times wider than on ECS. So it allows you, so on ECS, if you wanted to have like a sort of a 32 pixel wide image as a sprite, you needed to use 2 sprites to make that. Whereas with AGA, you can use just 1. So even though it's still limited to 8 sprites, and there are extra limits when you do scrolling and stuff like that, it's, you know, if you're making a complex screen, you start to lose sprites because your DMA slots are gone. So it basically sprites at the lowest priority. So when the chipset's running out of things it can do, so like, you know, audio and disk access and things like that take up DMA slots, basically sprites are last on the list. So if too many things are happening, like if you're getting too many bit planes, doing too many things at the same time during your screen draw, sprites start to go missing. So sometimes you can have very narrow, you know, you can make the screen very narrow, so you give yourself a bit of extra time at the start. Well, I'll see about touching on that later. But basically for the moment, like, you know, the thing is that AGA lets you to use big sprites, as well as combining it, you know, so some sprites can be 15 colors, some sprites can be 3 colors, and but basically if you make in Blitz, it will set up the sprite automatically based on the shape data that you feed it. So you can join a couple of sprites together to make a 32 pixel wide sprite, or you can switch on the AGA modes and use a single sprite, and the same image will do for both. Like, you know, Blitz will just automatically sort out the sprite channels as it needs, and the same with 16 color. So if you load a 16 color image, a 4-bit plane image, it will automatically create a double sprite, which is 2 4-color sprites on top of each other to make 16 colors. It will do that for you automatically, and automatically assume that's what you wanted to do. So when you're creating sprites, it's important to pay attention to the number of bit planes involved, the number of colors involved, because yeah, Blitz will determine what you do with your sprites, or how the sprites are set up based on that. So I know we were saying earlier that the bitplane hardware, or the chipset, uses certain pens for the sprites and stuff like that. So the sprites are taken from like colors 8 to 15 on OCS and ECS, and by default on AGA. If you even though there's colors 8 to 15, if you're creating sprites, they have to be colors like 0 to 3 for the first sprite, for example, or for the first 2 sprites, because they're the bit planes that are used. So, you know, so the hardware uses sprites the first 3 bit planes, even though they're using color registers that are further up in the list. The bit planes are like, you know, they're kind of bit planes 0, 1, and 2, and 3 if you're using 16 color sprites. So yeah, that was a bit rambling, wasn't it? So basically, you need to know what colors you're going to use, and you need to set up a separate drawing if it's on Blitz, if it's in Deluxe Paint or P-Paint or whatever you're using on the PC. You need to create the sprites with either 2 bit planes or 4 bit planes. No, sorry, 3 bit planes or... No, I was right, 2 bit planes or 4 bit planes. And that's it. Anything else, you won't get proper sprite colors. Or you probably get rejected by the debugger and probably cause all sorts of problems when you transfer more data than you should. So it's either a 4 color or 16 color image that you want to create for sprite objects. But there's our little sprite guy. And the cloud goes behind the trees. We'll ignore the bad colors. I'm not sure what's going on there. But these example files have been tinkered with over the years. But yep, so that makes sense. So let's look at that code now. So instead of drawing our stuff, we are just basically loading background and foreground images and the cloud image. Okay, so they're loaded as shapes, and that means we can blit them. So even though they're quite big, we can blit them. Oh, no, sorry, I have to get rid of these. No. Gone. Okay, so our bitmap is 1024 pixels wide. Oh, sorry, no, this is basically what we're doing here is we're loading in this wizard.iff file. Contains all the different frames of animation. I'll show you what they look like now. No, that was 9, isn't it? So, oh, was it 1? No. Tiles. Okay, there's our animation frames. Okay. That's what it looks like. Usually I set my background to a color that's like super bright and never going to be used. You know, just so it's easy to see what's actually black as well, because if you want actually to have black detail on the shape, you'll need to use something other than color 0, because color 0 is transparent. So we're loading in our wizard with the load bitmap command, and then we use get a shape to basically cut the animation frames out of that. Wizard.iff. Yeah. Why can't I see wizard.iff there? Oh, there's the original version of it. Yeah. I love that you're calling it hot pink and pink. It's yeah, I'm going to call it magenta. Why can't I see the wizard file? Oh, because it scrolls down as well, of course. Still can't see it. Anyway, we'll just have to leave it. But yeah, you just basically there are a lot of shapes. That's the original again. Okay, have to resort to this. Wizard.iff. There it is. No. Okay, there's our tile set there, and all our shapes there. Well, yeah, fair enough. Yeah, you can use any color. Like really, it's just that's an easy one to spot. Like, yeah, I used to use Directory Opus 5, and I really liked it. And when I'm using OS 4, I have the lister commodity running, which kind of gives you Opus type listers in Workbench. Like, so you can use, they're integrated with Workbench. Yeah, I don't know. I kind of I found that 3.9 was kind of enough, because when 3.9 came out, when 3.5 came out, it caused issues with Opus 5, and it got relegated to a Opus 4 kind of thing on a separate screen kind of situation. I wasn't bothered. Like, I ended up just using, using 3.5 and 3.9, which are kind of just about usable, enough to not bother me too much. So there you go. But anyways, that's what our sprite sheet looks like. So we've got 16 shapes there, all our animation frames. We load in that bitmap, which is 1024 by 80, and then we cut all our shapes out of it. All 15 shapes, and each shape is 64 wide. So that's using the full capabilities of AGA there. We've got our palette saved in a separate file. I tend to use that because if you have a few different if you have a few different sort of setups, like you've got file for your sprites, and file for your background, file for your foreground and stuff like that, and files for certain objects and stuff. They might all have different palettes, even though they're all going to use the same palette at the end. And I use a single file to do that, rather than trying to set up extra depth in some of the files to contain the palette in it. So a separate palette object, you can save them from Personal Paint. I wrote the no graphics. I wrote palette ed, and that's quite nice for editing palettes, because it gives you this kind of layout here. And so this is what I wrote, basically to solve all the problems. But if you look, it'll give you sort of little tool tips here to tell you which like AGA Bank 0, AGA Bank 1, and there you go. But it lets you kind of like import palettes into and move them around in a chunk, like, so you can just shift click that and then move them to somewhere, and so you move them to, let's say, there. Now that's kind of messed up because we've got a shades of grey down here, but Right Amiga full stop temporarily restores the palette, and then as soon as you click, it goes back to where it was. But yeah, it's a nice little palette editor, that, if I do say so myself. The undo doesn't always work, does it? Yeah, there you go. And it has all the HTML colors as well. So if you have a color that you want, you can use that, and you can stick that in somewhere instead. But that also lets you import. Yeah, so let's say, like you see the wizard there is using colors 0 to 15. Okay. But if you load that in, and that's probably why our demo was corrupted earlier, because the palette wasn't taking that into account, whatever demo I was looking at earlier. So we don't want the sprite to use colors 0 to 15, even though it does in this image here, because it's only a 16 color image. So so what we're going to do is, actually now for shits and giggles, we'll load in that palette. Articles, tutorial 9, tutorial 9. So so let's have a look at our palette and just see how it's laid out. Palette. So this is our palette, and we can see we've got our hot pink. A shapes manager would be nice. All right, yeah, I'll bear that in mind after I've done everything else. Okay, so you can see here, basically this is a 64 color palette. Okay. Hot pink for the background. We set that manually to black after I load in the palette. That's fine. But then we've got all the greens for the foreground. Up to there. Now you have to ignore that it changes to dual playfield background there. I'm pointing at the screen. You can't see where I'm pointing, but follow the mouse. It changes to dual playfield background there because that's for ECS. With AGA, you're going to move that around, so it doesn't really make a difference. But that's AGA goes as far as there. So that basically on AGA systems is your foreground, and then we've moved this to be our background, so you can see the mountain colors and stuff like that there. And now, so AGA Bank 2 is where we've moved our sprite colors to, and that goes up to there. And then AGA Bank 3 is where more sprite colors go, and these are our wizard colors, so you can see there. So all our wizard colors are in there. The problem is, I think that the cloud is loaded as an even or odd sprite, but you see the way those colors are inserted there. So what I can do is I can insert a palette. You see, and I can choose a palette, and it will insert that palette at that point rather than at the very start. And so that means that I can load, let's say, the wizard colors and load them into start there. Watch. So let's just imagine that yeah, those colors weren't there. So they're not the wizard colors anymore. But if I click there, I can go to insert from file, and then that'll be the same. Yeah. And I can go to my palette file or my wizard file and get the palette from that. And yeah, we can even load it as a preview. Now, this preview is going to be totally wrong because it's treating this like a bitmap, not a set of sprites. But there you go. You get where I'm coming from, though, that this is from there on, that's the bank that we're using. This is AGA Bank 3. And I'll show you how we set up AGA Bank 3 now in a minute. But yeah, so and it also lets you load in an image as a preview. But there you go. Also written in Blitz Basic for the non-game fans out there. But anyways, there you go. That's kind of how I deal with the palettes. So it makes it easier to digest. So that's why it kind of makes a lot more sense to save it as a separate palette. Even if you do it in Deluxe Paint and save the palette out, it means you don't have to have bitmaps that have the full 64 colors in them. You just save it as a separate palette instead. Yeah, because these bitmaps will both be 16 colors, the foreground and background. Cloud will be a 4-color bitmap. Now, here we have our first bit of sprite code. Get a sprite. And what that does is, you can see there, sprite number and shape number. Sprite number 0, like all the other Blitz objects, start at 0, and you've got loads of them there. And you reference through the sprite number. Now, it's important to note that when you're saying a sprite object here, we're not talking about the sprite channel. So it's an important concept to grasp. But the Amiga hardware has 8 sprite channels. Okay, that's a hard limitation that is the maximum number of sprites you can display on the screen at any one time, barring some tricks. Okay, now 8 channels means that you can go do 8 16 wide sprites, 3 colors each, or you can combine them, but then you get, like, you know, then you're losing sprites. So combine sprites 1 and 2, then you get a 15 color sprite, or you get a 32 pixel wide sprite at 3 colors. Now I'm talking ECS here. AGA, you can obviously make them wider, but in Blitz you've got a sprite object, and that is just a shape. That's just a bitmap that you can apply to a sprite channel, that you can basically get a sprite channel to point at. So you have to have these shapes set up in memory in chip RAM, and when you want to display it, you tell it this sprite, you tell Blitz which sprite object to use on which channel, and that's how you display a sprite. But so when we're loading sprite here, we're doing sprite number 0. That doesn't mean it's channel 0. That's sprite object 0, and we're putting shape 2 in there. So you can see there, shape 2 is our cloud, and that means now sprite 0 is a cloud. Then we load our wizard, and we do get a shape here, which creates shapes from the bitmap, and we start at let me see. Shape number. So yeah, basically we're just reusing the same shape again, shape 2, and with that, and then every time we're making a new sprite object, so we don't have to have all those shapes in memory. Once you create a sprite object, it copies the bit planes from the shape object to the sprite object. That means you don't need the shape object anymore. You've got sort of 2 copies. One is a shape for blitting, one is a sprite for displaying on a sprite channel. Both the same bitmaps, slightly different properties on each, but both the same bitmaps. So you don't need both copies. So once you've created your sprite, if you don't need the shape, you can reuse the shape for something else, or you can free it up with the free shape command there. And that gives you your chip RAM back, and free bitmap does the same thing. When you load in a bitmap, if you don't need it, get rid of it. Don't do it too much, as in don't go through a loop loading in 1,000 shapes and free it up each time you iterate the loop, because that'll just fragment your memory to bits, and yeah, nothing good will come of that. But yeah, free it up afterwards by all means when you're finished with the stuff, finished with loading in the assets. Okay, so this is just a fancy way of, like, you know, saying it's 64 pixel intervals. Take out a shape that's 64 wide and 80 tall, and get a sprite. We're doing so I+1. So the wizard starts at 1 to 16, and each time it's just copying in shape 2. All right. Then we ditch them, get our memory back. We load our palette. Now, normally we do pal or GB, and that lets you set a palette register, like a color in a palette object, not literally on the screen. But so we're going palette 1, register 0, 0, 0, 0 for red, green, and blue. But if you put AGA in front of that, instead of taking 0 to 15 as values, it takes 0 to 255. So the full range of the AGA 8-bit color. That's fine. Now we're making up our new bitmap. So what we're doing here is, it's a bit slightly lazy, I suppose, but bitmap 2, that's our foreground. So this is the grass and the trees and stuff. We're loading in the shape. We've created a bitmap that's 960 wide. We've got our shape loaded as foreground, shape 1. Oh. Yeah, so, and we blit that basically at the start of the bitmap, and then we just use the scroll command to multiply that over to the other side of the bitmap. So you have 2 copies of the bitmap, and that just means, you know, we've got space to scroll, and then we can go back to the start again. That's all. And then we're doing the same with the background. And the background they're different widths because it's a dual Playfield display. You don't have to have anything matching up particularly like that. You can use 2 different widths. Again, inefficient way of doing it, but I'm making a long picture that we can just scroll by. And repeating the first 320 pixels basically means that when you get to the end, you're showing exactly the same picture as the start. And that means you can jump invisibly from one end of the bitmap to the other to get back to where you were. And we do the same with that. Same with bitmap 3. We load it in. We blit the shape and we scroll the first 320 by 200 pixels to 680 pixels along. So we basically, again, copying the start to the end. Now the bitmap is created so that it matches up nicely like that. But you know, that's easy enough to do. You just kind of like, well, I think how I did it was just took a certain portion of it and mirrored it, and then attached the extra screen on the end. So that's it. So, but the scroll is there. It's just copying a big chunk of the bitmap to another place. Now we can free both those shapes. They're quite big shapes. Good to free them up. And now we're using a new type for our image info. So image info we define up here is just an X position and a speed. And we're using that for a foreground, background, cloud, and player. They all have the same kind of properties. So we're using, it's nice to have the same type of thing available for them, or you know, to be able to access them the same way. So foreground, background, cloud, player, each of them has a speed and an X position. And here we have our subpixel scrolling again, because they're quick variables. Cloud X speed is doing quarter pixel scrolling to the left, minus 0.25. So every frame that moves a quarter pixel to the left. Starts at 300 across, so just starts at the start of the screen, and then and the player starts 100 across. Now the anim frame is just a variable I've set up. I'm using a quick there. It's a bit of a shortcut using a quick, and I probably need, you know, I'll show you what that's used for in a minute. And direction is just like a word variable. Now, here's the thing. I add a delay before going into Blitz mode, because Blitz mode, once you hit this, it shuts down the operating system immediately. Now I'm using a V-wait 50 there, so that just waits for 50 frames before that executes, and the reason for that is to allow any disk activity to finish. So any of the loading of shapes up here, you want that to finish, and especially if you're going to run something from floppy, you want all disk activity to be finished before you go into Blitz mode, because if you don't, what'll happen is it'll be in Blitz mode and you'll be in Blitz mode and the floppy will keep spinning and spin, and you don't want that. So it's not the end of the world, but if you leave the game on for a while, it'll eventually wear a trace through your floppy disk. But coming from hard disk, it's less a big deal, because especially if you're just loading stuff, but you know, because a hard disk will finish accessing probably by the time you've done all your bitmap setting up and stuff. But floppy drives being quite slow, you want that activity to be finished, so I just give it a bit of a wait. And then we create a display. We've set up our cop list up here. There's nothing particularly special about it. Oh, well, there is. This number customs, I went over that before. Basically, you've got two different ways of adding custom cop list commands to a display in Blitz. You can do it the manual way and use your interrupts and poke pointers in, but to use the ready rolled commands, you need to give them space. And so basically what this does, this reserves space in the copper list to add your commands. So there are two different families of commands, and one gives you a positive number, one gives you a negative number, and so you can't use both of them together. You have to choose one family or the other, and when you do, basically, you know, one will say it needs 4 bytes of cop list space. You have to add a -4 on if it's one family, and a +4 if it's the other family. That's kind of how it works. So this is display rainbow, this command here. So what display rainbow does is that sets up the copper gradient that you see in the background. And if you look at the documentation for Display Rainbow, you will see that for an ECS palette it needs 1 byte of space, and for AGA it needs 4. But because it's a display family command, the two families are display and custom, and all the commands start with display and in the display family, and all the copper commands with custom begin with custom, and they're plus values, and display are minus values. So this one says I need 4 bytes to do an AGA palette, and so that's what I gave it in the display setup. The help is terrible on that, but basically what we're saying is we want cop list 0 and color register 0 to use palette number 2. So what we've done is init palette 2, and this is, we're doing some slightly funky stuff here. This is basically setting up a 256 color palette, and we are basically just drawing some colors to it using some fancy maths. That's all. So well, it's one line basically. Display Rainbow and display RGB. What display RGB does is it gives you a particular point in the screen, in a particular line on the screen, basically, to where to apply an RGB change. So what these are both doing is they are changing the colors of color register 0, let's say, on a Y position of the screen. So Display Rainbow is basically just automating it. So what it does is it will change the colors based on when you load in a palette. So the first line is color 0, the second line is color 1, the third line is color 2. It means you can make your gradient in Deluxe Paint. Yeah, exactly. Yeah, that's all. So it just means that you could use palette ed to create a spread of colors, for example, and load that in as a palette object, and then just apply it, and it's literally just one line. It's as simple as that. It's very, very easy, and all it's doing is, as JC says, is inserting those, running that loop for you. You know, it's inserting a special custom command every line, all the way down to apply that particular color. Yeah, so you see, you can have multiple palette objects, you see. So this is palette 2. This is unrelated to what's displayed on the screen. This is just like a palette object is just a list of colors, like literally a list of numbers. That's all that correspond to colors. So yes, you can have any number of palette objects you want. All a palette object is a list of RGB values. If you apply a palette to your display, then see the display palette here. We loaded palette 1. That was the one we had saved on disk, and that's our game palette. But when you go to display palette, it copies all the values from palette 1 into the display 0, cop list 0. So the copper then uses those numbers. But the display, the actual palette object is still just a list of numbers in memory that have now been copied. You can still modify it, and it won't actually modify your game. But yeah, I've just set up a separate one. You can have any number you want. There's probably a practical limit to how much you want, but like the default is 4, but you can change that. Like if you wanted to have 400 different palettes, go nuts. You just, yeah. But yeah, so that's yeah, that's it. So you can make up a separate palette, and I'm sure that'll be very pretty if you use your games palette for the Display Rainbow. That would be odd. Yeah, so the number of yeah, the number of shapes is the number of shapes. Yeah, I should go through that actually. All Blitz objects are limited in the number that you can have. Okay, So, and they're all in here. In Blitz 2, you've got a slightly uglier version of this window. But that's basically it. All the different objects are there. Yeah, you can update them. So shape defaults to 100, but you can yeah, you can do 1,000, whatever. Now there is a practical limit on that in Blitz 2, which has been removed for Blitz 3, and basically it's the limit. The limit is, what did we say? It is 32 bytes. Basically, it's whatever many number of shape objects fit into a word variable. So 32,768 is your limit. If a shape variable is 32 bytes, then you can have 1,024 shapes, and that's your limit. But if you go beyond that, it won't tell you. Like if you set it to 2,000 and you load in 2,000 shapes, you're just going to get nasty things happening. Yeah, all sorts of corruption, memory problems and stuff. Yeah, the rainbow effect is just changing color 0 or whatever color you want. You can set it to do register 1, because like we were discussing earlier, if you're aiming a game at OCS, you get overspill at the sides of the screen for your rainbow effect that you can't turn off on color 0, because color 0 extends beyond. You can't turn off the drawing in the borders. ECS and AGA you can, and then the copper effect gets cropped to your screen as well. So you might want to swap to use a different pen for it, and manipulate your graphics to do that. So yeah, that's just worth bearing in mind as well. That you can apply to any pen, not just pen 0. Now, so basically this is all we're doing is yeah, that's it, exactly. Yeah, you can use whatever color you want, but yeah, so display rainbow is just like a neat way of doing that, and it means you can use Deluxe Paint or Palette Ed for setting up your gradient, which means you don't have to kind of think about it as much. You can do it whatever way you want, set whatever values you want. And if it's AGA, it uses the full AGA palette, which means nice smooth gradients. And OCS, ECS, will can use the same palette actually. It'll load the same palette, and it will just round it to the nearest 4 bits, or probably crop it to 4 bits. Yeah. I will just show you that same window in compiler options. But yeah, so basically there is a limit of about 1,000 shapes in Blitz 2. It's a higher number in Ami Blitz 3, but that's where you do the same thing in here. So you can set the number there. Yeah, there's shapes 100 there. Yep, indeed. So I'm using fancy math here to do like kind of a semi-realistic evening gradient, but you can go mad with it. You can do whatever you want. There. Okay, now here's our main loop, which is just repeat until, and that's just our joy beat. That's our mouse button. If we press a mouse button, that will quit. So first thing we do is we don't need any double buffering because we're only using sprites. But we do a V-weight so that's nice and smooth, because you don't want to change your bitmap position halfway down the frame, because then you get tearing. So you do a V-weight before you do a scroll, and you do the display bitmap 0.2. So that's basically foreground bitmap is bitmap 2, and foreground X position, and then background bitmap 3 X position, and there's no Y position. It's the same height as the screen, so that's set like that. Okay, and now here's where we do our sprites. So display sprite is so we want to use coplet 0, and sprite object 0. X and Y is cloud X position, and Y is 10 from the top, and then sprite channel. This is where we were using our actual hardware. Okay, so that's sprite channel 2, and the reason for that is we've just decided to use channel channel 0 for the player, for the wizard. Now the reason we're using 0 is when you combine sprites. So the wizard is a 15 color sprite. When you combine sprites, it uses 2 channels. Okay, it's one object, one blitz. sprite object, but there are 2 channels involved because it's 15 colors. So it automatically, you tell it the even channel and it automatically uses the next odd channel as well. So if you say channel 0, it will use 0 and 1 for a 15 color sprite. No worries, Nivrig. Thanks very much for coming along. And yeah, cheers. I'll probably be doing a bit more this weekend. I've got the in-laws staying next week, so I actually mightn't be streaming next week. But yeah, I will talk to you soon. And good night. And I'm sure I'll chat to you on Discord tomorrow. I mean, working. Yeah. So what we're doing here for the player is, instead of doing shape 0, or shape object 0, or sprite object 0, sorry, we're doing a sprite object based on the anim frame value. But we want the integer value because anim frame is a fractional, it's a quick variable, and we're moving it in fractions, and we're just going to get an int of it here. I'll go through another way of doing this in a minute, which might be more efficient. Just bear with me though. All we're looking for here is the integer part of that number. And int gives you the integer part. It gives you a whole number. But all it does is it just drops the binary part. It doesn't do any rounding. Like so, if it's 4.9 and you get the int of that, it'll just be 4. It won't be 5. Okay. So, and then we just display that at the X position and 70 from the top of the screen. That's it. And sprite channel 0, as I said. So now the reason for that anim frame being that is we are updating the anim frame position by the foreground X speed divided by 10. So it's a fractional thing. So basically what that means is that every time the foreground moves by 1 pixel, the anim frame is upped by 0.1. Okay, so that means that, look, okay, we've got 8 frames of animation in each direction. So numbered 0 to 7, let's say, for either direction. Let's ignore the direction for now, but it means that we're displaying frame 0. In 10 pixels time, we want to display frame 1, so we update the frame counter by 0.1 until it becomes 10 pixels later, it becomes the second frame, and then it displays the second frame for the next 10 pixels, and so on. So that's why we're using a fractional number, even though it's an integer. You could do it all integers by using a separate counter, but yes, exactly, that's exactly what I'm saying. Now I'm not using floats, I'm using fixed points, so at least it's not that bad. But it's 16.16 numbers. That's what a quick is in Blitz. But yeah, this is kind of for understanding. I've done it this way, but what you can do is you can set up an extra variable that just counts to 10, and when it counts to 10 it increments the frame counter, and then both of them can be integers, both of them can be bytes. So, and then that saves the problem, or words. Yeah, it's not so bad. It's still, you know, twice as big as it needs to be for an integer, but you know, yeah, when you're on AGA, you can do it all. You can read and write it quick in one cycle anyway. It's more using quicks on it at 68,000 that's bad, as in, you know, 2 memory accesses to load it. So yeah, so it's not too bad. It's kind of less of a big deal on AGA, but still, for doing calculations with it, you want, you know, it might be nicer to set up a counter and do it that way. The same with QWrap here. QWrap works on quick values. Yeah, that's it. Might be, yeah, but QWrap is more. QWrap works on quick values as well, so I'm using that for seeing as we're already dealing with quicks for our speeds and our fractional scaling and stuff like that. It's, you know, it's all in quicks, so it's fine. But QWrap will wrap around the number. But if it's an integer, if you're using a word, it's quicker not to use QWrap because it tries to do things with the extra. It's, you know, it's trying to do something with the extra with the extra 16 bits of information. And it's, yeah, especially on like I said, especially on a 68K, don't use QWrap unless you're using quick values. it's quicker just to write your own using, if it's greater than this, then subtract that. Now I'm going to finish up now once we've done this, but yeah, so then basically that's it. So foreground is the same. We're changing this. We're doing the speeds here. We're just adding on the speed variable and wrapping it around so that it goes back to the beginning of the bitmap again. And that's it. So yeah, and see the actual position of the cloud. By the way, just I should have pointed out, just for clarity, that sprite X and Y positions are based on the screen, not on the bitmap. So it doesn't matter where in the bitmap you're displaying. Sprites are independent of bitmaps. They don't have anything to do with bitmaps well, basically all the way up until the actual video data is generated for the output. They're entirely separate, and that's how they work. Where you don't have to redraw anything or anything like that. So you just have to bear in mind that you don't need to calculate. If your sprite is to move with the bitmap, you need to keep them in sync. You need to do that manually, effectively. But what we're doing with the cloud here, you can see, is we're going down to a position of -64. So sprites can also be positioned at any position on the screen, way beyond the borders, and unlike blitting, it won't do you any harm putting them beyond the limits of your screen. It just won't get drawn. And and as Nivrik pointed out the other day, that will actually save you a DMA slot if they're beyond the limits of the screen. So it might be a good thing to do. But this means that the cloud can scroll all the way off the screen, because if it's a wide sprite, like you don't want it to sort of get to the edge. I'm going to try and demonstrate this on the camera. You don't want it to get to the edge here and then disappear. You want it to go all the way off the edge. So it scrolls to a position of -64 pixels, and that's a perfectly legitimate position for a sprite. -64 is way beyond view over here, and beyond the overscan as well. And then it'll wrap around to position 360, which again is beyond the other side. And so you don't want it to appear here either. You want it to appear here and then scroll on. You see, and that's how it works. So that's why we're doing funny things. But it's an easy way of making a sprite disappear, is just to give it an X value of -50 or something. That was one sprite replicated all the way. Yeah, that's doable. I'm not going to go into repeating sprites on a line, but that's a copper trick where you can get the same sprite to appear multiple times. Yeah, but that's a common one, and that's if you've got the same imagery, that's a nice way of doing it. Yeah, yeah. I haven't actually done that myself, but basically there is a way of adding custom copper commands to Blitz, as well as the kind of the pre-rolled commands like display rainbow. There's a way of inserting custom things. Yeah. There you go. Now, but it's yeah, there are plenty of kind of assembly guides on doing that around the place. So it's just a matter of kind of translating that to Blitz. But yeah, so that is well, it's sort of a roll your own cop list, but yeah, yeah, you need to insert the commands at the right place. So because Blitz doesn't have a ready rolled repeat your sprite command, so you have to do custom cops, and that lets you insert an arbitrary number of bytes into the cop list. So you're not entirely making it yourself, but you just need to allocate the space and yeah, shove it in there. Yeah, so that's basically it. And then all we're doing is we're changing the speed down at the bottom based on what the joystick is doing. You see? Yeah, exactly. Yeah, you can do it. Now, Blitz has a way of multiplexing sprites horizontally, basically resetting the sprites at a certain Y value, and you can do it, and that's fine. But yeah, horizontally it's a bit more involved, because yeah, you have to trigger the reset command or change the pointer at precisely the point in between where the two are displayed. So yeah, it's doable, obviously, and people do it all the time. But yeah, it's slightly more involved. But and Blitz doesn't have a ready to go command for that, unfortunately, which is a shame. But basically, this is all we're doing here is changing the speed based on the joystick. So like the Q wrap function here, which wraps the number round when it gets up above a certain thing, it wraps back down to the lower value. Q limit does the same thing, but just limits the value. So you know, it basically will. So it's basically saying that our speed can only be between -5 and +5. So if JX, oh, and a little tip for avoiding weird bugs in games: if you're reading the joystick, don't do multiple reads of the joystick. Like I'm reading the JX there, into the JX variable. You know, you can do it, but first off, it's a bit slower because you have to go through accessing those registers again, and reading the joystick in the X and Y direction is kind of it's a two-step process, and you have to like read 2 registers and then do a bit shift on one of them and them or something. I can't remember exactly, but basically it's slightly more expensive than just reading the value from RAM to read it multiple times. But as well as that, you can have a situation where if you read the JoyX when, you know, at one point and then you read it again at another point, you can get that the player has just moved the joystick in between those 2 lines of code, and you get weird kind of bugs. So just bear in mind that maybe once a loop read your joystick. There is a joy or command, and it depends on your game which one works best for you. The joy or command gives a rotational thing, so it gives I think 0 to 7 going clockwise for the 8 directions of a joystick. Similar idea, don't read it more than once in a loop, because it can, you know, it'll just waste cycles, and it can cause you bugs. Where, you know, it might appear that someone can go both directions at the same time, and that can cause you problems. But yeah, so but the JoyX, JoyY do just the X and Y, and it depends on how your game's made up whether one or the other makes sense, but they both basically do the same thing. But yeah, so that's basically it. So and then all we're doing is if our speed ends up being 0, we're setting the anim frame manually to the first one, which is just standing still. And then if the speed is less than 0, the direction is 8, and if it's greater than 0, the direction is 0. So what that'll do is that will swap the direction around by adding on 8 to the frame number, the sprite object number that we're using. And that's kind of how we do. So the first 8 frames are going pointing to the right, second 8 are pointing to the left. That's it. Yeah, and it also kind of deals with diagonals and stuff like that. But yeah, it depends on how your game is set up, really. Yeah, and you'll find one will work better than the other depending on what, you know, how it is. But yeah, there you go. I will leave it there. But well, before I go, is that all making sense to everyone? This sprite stuff and kind of what I'm doing here with the maths and jiggery pokery. Oh, the one other thing I was going to do, yes, is our display controls command for this one. So now you can see what we're doing here. We're doing the first parameter needs to be exclusive ORed, the second parameter does not need to be exclusive ORed, and the third parameter needs to be exclusive ORed. Very annoying. And that's kind of a bug in the display controls command, I would assume. But there's so much stuff written with that in mind that it's probably a nasty thing to try and fix now. Anyways, yeah, yeah, something for fresh on a weekend morning or something. Absolutely. But anyways, what we're doing here is we're setting this up for display 0, for cop list 0. Now we're turning on. This is this value here. These bits set the playfield priority. So 100001. If we look at that in our list here, 100001. Okay, so Playfield 2 priority 2 and Playfield 1 priority 0. Okay, so that makes Playfield 2 priority 0 the frontmost thing, and Playfield 2 the rear priority is the rearmost thing. But what we have as well as that is the sprite priority, which is oh yeah, no, sorry, that's sorry, yeah, so sorry, yes, sorry, yeah, I've explained that. Right, playfield priority is where that particular playfield fits within the sprite channels. Okay, so playfield 1 priority 1, 0, 1 and 2. So basically if you set that to the maximum, you're setting it behind all 7 channels, but it has to be in pairs, like so you can have channels 0 and 1 in front of it, or 0, 1, 2, 3 in front of it, or 0, 1, 2, 3, 4, 5 in front of it, or all 8 in front of it. And that's basically you're choosing where it slots in. So so with 0, it's at the very, very front of everything. The 1, it's behind channel 0 and 1, and so on. So that's we can experiment with that now, and I'll show you. And then it's the same with Playfield 2. We want Playfield 2 behind all of them, so that the clouds go in front of Playfield 2 and behind Playfield 1. So let's say, for example, let's say we do we change that to 100. Oh, I shouldn't have run it in this one, should I? Oh, it works. And it works in this one with the right cloud colors. But you can see there now the cloud goes in front of the tree. Now watch this crash out on me. So that was channel 1 basically. That we bumped up the priority, so it was in front of everything. So channel 0 and 1. So, or sorry, it was in front of Playfield 1. And then we can do the same with the mountains. Move them back up here in the background. And you can see now the cloud goes behind the mountains. So the cloud has the lowest priority. That one. Okay. So yeah. Now let me think how exactly that works. Oh. And a better explanation of this actually in the ROM kernel manuals. They have some nice diagrams on Playfield's priorities. And but yeah, so basically, yeah, that chooses where your playfields slot in between the sprite channels. So yeah, so you can choose how many are in front of both, how many are between them, and how many are behind both. And that's what that means there. Now the other thing we're changing is, we changed this to 1C00, so the second playfield starts at pen 16 instead of pen 8. And then the third one is, and we're choosing sprite bank 3 for odd and joint sprites, and bank 2 for even sprites. So if you have it, yeah, okay, so if you have a joint sprite, and that's what's called like a double sprite, like is called a joint sprite when you've got either double width or double depth. So like the 16 color sprites, they're called a joint sprite because 2 sprites join together in kind of, and they basically take on the properties of one sprite, but the second channel in there gets unusable. But if you have joint sprites, will use the odd colored, the same channels as the odd sprites, whatever bank that is. and even sprites are set to bank 2. So that's, I don't know why it isn't working on the other thing, and it might be a bug somewhere in Blitz actually, but that's setting the right value. So we can see here, so hex 23 is the default value, and we want to do hex 11. Oh no, that's not what we wanted. That one. So hex 11 is yeah, offset for the odds price. So you're setting up these two. Hex 23. Let me think. Oh yeah, sorry. So yeah, we're adding 1 to each of those bytes. Let me see, or each of those words. Sorry, that's not what I wanted. It's this one. Yeah, so basically we're setting up these 2 offsets here. So 4567 and 4567 are the yeah, basically are what we're changing there. And yeah, so that's basically just shifting the pallets up by one bank effectively. So the banks 3 and 4 instead of the banks 2 and 3 instead of bank 1. So that's basically giving us our colors for the wizard in bank 3 and the colors for the cloud in bank 2. So, but yeah, see, so the default value for those are 224 and 23, and that's what we're doing here. Is I'll show you that now. They're up at the top, 224, and oh, sorry, no, it's 11. That makes more sense to me. Okay. Sorry, yeah, that makes more sense. So 11 is the default. So 23 is putting a 2 in this nibble and a 3 in this nibble, and so that's setting your bank numbers for both of those sets of colors. And so you exclusive OR that with 11, and that gives you the values that are supposed to be in there, and then you exclusive OR with 224 to get the values that are supposed to be in there with your priorities. Slightly convoluted, sorry about that. But yeah, it's a bit of a funny thing, but if you look at the ROM kernel manuals, it does have some decent diagrams and explanation in there of those registers. It's just a bit funny to use them on Blitz because of this exclusive OR thing. Now, any last minute questions, or will I go to bed? I'll take that as a no. No last minute questions. Excellent news. Right, so what I'll do is I'm going to see who is on Twitch at this late hour and give someone a raid. Who is on? Nobody around. 5 past midnight on a Tuesday is not a good time, I suppose. Sure, we'll jump into Amiga Live there because that's usually kind of fine. And yeah, we'll give that a go. Okay, so let's do that. Hold on a second now and I'll do that. But yeah, everyone's happy with that. Excellent. Thank you very much for coming along, guys. Thank you, everyone. And if you have any questions, go and have a look in the Discord. And oh, does he? Yeah, and let's see. Am I even following him? Oh, he's running late. Yeah, no problem at all. No problem at all. Yeah, good stuff. Yeah, ask questions in the Discord if you need it. I am going to let's see. Yeah, 48k RAM is not around. But yeah, so we'll go and raid. Oh, what's today? Tuesday. Right. So leave it up to you guys. Amiga Live or that girl Joey? Where are we going? That girl Joey is doing Commodore 64 stuff. So yeah. Where we go? Where we go? Anyone? No. No one cares. Okay. Right. Yeah, fair enough. Yeah, no worries. Okay, we'll go to Amiga Live. And Cool. Yeah. No, thanks very much for coming along, guys. It has been fun for me too. And I ate loads of very, very salty nuts. It's excellent stuff. Now, right. Oh, where's my tiggy? Good night. And yeah, I'll chat again soon. Bye-bye.